Hello everyone, welcome into yet another stream, and oh yes! Finally! We get to get rid of this lovely make it. Hi there everyone, hi there 6A7 M. Hi the con, hi, welcome, hi. Let me just play some music. And finally we get to get rid of this make it. I've been waiting for this for a while. So at Soda KC Music on the YouTube. That's where the songs are coming from. There we go. Sick. A little bit loud. Sick. Let me open everything up. It feels like it's been like at least 10 days since we did this last time. Today what are we gonna do? We are going to get rid of this Lord awful 3D make it in the corner, the farmer one. We're gonna replace him with a better make it. This might actually be pretty easy. We've been doing a lot of long streams recently, so I feel like I might do a shorter one just for a change. Because wow, we've been doing a lot of long streams recently. Alright. So, for those who don't know, every 10 days we switch up the make in the corner. This one, this little guy, this little bugger. And Patreons get to decide what the new make it should look like. And it has been decided that this week it's gonna be a wooden pirate. Well, 10 days, yeah. Yeah, 10 days, yeah. This is actually the 4th one, I think. Wait, we had 3D make it, Makita, Science make it. Oh yeah, and then, yeah, this is the 4th one. So this will be 5th. 5th make it. And so this actually will be an extremely easy one to make. Now I'm thinking about this. This really will be an easy one to make. Oh no, I'm gonna finish making that. That can't be it. Because that really will be an easy one to make. Okay, let me just location rotation this soul sucker. And so basic idea looks like this. We have these frames. This is the passive one, passive make it. We can replace his hand with a hook. That's a good idea. Left or right? With the pirate, they need a hook. Okay, that's what we're gonna do. We're gonna replace make its hand with a hook. Damn it, always something, absolutely always something. Why is this a single mesh? Never mind, it's not linked. Festive, this is actually pretty good. There, and then make it a missing hand. Hi there, guy. And so yeah, actually the whole process will be really simple. Because all we'll need is just the wooden texture, and that's it. That's actually kind of it. They all have different textures, but well, we'll fix that in post. So basically you want to remove all of these and then pick a good wooden texture. What will be the new make it? It will be wooden pirate. Wooden pirate statue. That's the new make it. Which means we're just gonna switch that bad boy to wood mode, then add a hook, and then add a captain hat. So hold on, where's my wood textures? Wood fine dark, no, it's too glossy. Flooring, not quite what we're looking for. Wood plank sworn, no, that'll be paint to texture. I don't think I have a good enough wood texture actually. This one could work, maybe. I mean, it's gonna be unwrapped all willy-nilly. Yeah, precisely. And then normal, right here. And then reflection, right. I'm sorry, what? How is this working? Okay, this into roughness, but then invert the thing, yeah. Displacement into displacement, and this into displacement, and that's supposed to be a wooden texture. We'll have an eye patch and a parrot. Oh yeah, there are so many parrot things I could add actually. A parrot, I don't know. Depends if I have the model. I'm not modeling a parrot today. RGB curves, there we go. This doesn't feel wooden. Oh yeah, that makes sense. Okay, sky texture. Let's add a nice sky texture. Maybe that's the problem. Maybe it's because the lightning is all funky. And sun intensity a bit down, there we go. Yeah, that's, I would say, a bit more wooden. Not quite what I'm looking for though, something is off. Maybe I just need to switch up the entire make it. Over top? Yeah, there we go. Let's switch up the entire make it. Just to the wood texture. Outfit top. Outfit top. Outfit top. And might as well the boots even though they're not in frame. Alright. There we go. Is that supposed to be wood? I don't know, it feels... Parrot might be difficult. No, I'm just gonna get a model from the internet, the World Wide Webs. Oh, this looks much more wooden. There. Wouldn't make it. There we go. That's wouldn't make it. Wasn't that difficult. Now what we need is we need a cylinder. Which, oh, I forgot how many things we had right here for absolutely no good reason. There we go, and then add a cylinder. And this cylinder is gonna be shorter. I'm just gonna switch to this because it might annoy some people. And then we're gonna select the ring, we're gonna go in, we're gonna go down, we're gonna go in, we're gonna go even more in, we're going to go out. We're going to go out. We're going to... no. How do I even... There was like a way to curve it around something, like a modifier. Shear, not quite shear. Spin, maybe. Okay, I think spin is what I'm looking for. But I have no idea how to use spin. Okay, so angle 0. Center high up. Right here. Oh, I see. Do I see? I don't... Do I... Do I see? It... So... There. Why is it only rotating like around? Okay, I can figure this out. I'm smart. Jeez, it's not gonna be easy. Spin is not what you're looking for, but I know either how to do it. I mean, I don't know. Feels like yeah, I could do the spin. Okay, this is gonna just rotate. Hold on. Let's tackle this one by one. This is gonna rotate this around, so we don't actually care. But why? Oh yeah, we need them to set to something in order for this to actually work, right? Not what we care about. This one is moving it in this angle, not quite. Okay, okay, okay. Angle just how much? Alright. What if, hear me out, what if we do this, this, and then spin? Not better at all, one bit. It's cool, it's fine, it's fine. I can figure this out, I'm smart. This is not quite what I was looking for. Okay, hold on. I mean, I had no one way to do it, but it's gonna be a pain if I do it that way. Because one way to do it would be just do it like this. You know, make a hook manually and then fix it in post by rotating all of those. Maybe that's a better way to do it, you know? Wait, can't I just do spin around and then rotate them? Hold on. Can't I just spin around and then rotate? Like this? No, we need it to be flat. Which one controls the flatness? This one. Sick. 0. Neat. Yes. Almost. Angle back. Rotate to like a full one just to make it easier for myself. There. I can do it, right? If I lower the steps to something like 4, 5, 6. I'll just end up doing it manually, won't I? Oh well, the price you pay. The price you pay, am I right? Then we'll have to move this entire thing. I should have increased the angle before I did that. Whoops. This ain't gonna be much of a help. I guess I can select it like this. I said like, no, I said I can select it like this, You don't listen. There, that's what I meant. Sick, and then last one. Alright, now we just need to model into a hook. That's, you know what, fine, we're doing it manually. As if anyone actually cares. Well, don't select those, please. Neat. And now it's time to fiddle with for 2 hours. Subdivision surface. Obviously subdivision surface is screwed up at the end, that makes sense. And yeah, the pirate life. Savvy. Make it, how many hours do you have on Blender? I know, I have to check my Steam statistics. Right, looks good enough. There we go, we have to delete this. But that shouldn't be too difficult. Just, can I link? Oh, hell yeah. I like it when models walk with me. That's a huge hook. There is no need for a hook this size. Then we're gonna select this one. Bone. And now, there we go! We got a pirate make it. With a hook. Alright, sick. The bigger the better. No, size doesn't matter, okay? Don't hurt. Size doesn't matter, okay? Size is just the color anyway. And lower this down, up the metallic, lower the roughness. There, what a lovely hook. Am I right or am I right? God, this is the pirate life for me. It's the sharpness, precisely. It's the shape that matters. Alright, so that's the beginning. Actually, we're really quick at these streams, aren't we? It's 20 minutes in. Now the hat, I suppose. An eye patch would be a good way to go too, because an eye patch would be easy. An eye patch is a cylinder, like this. So you can position like so, and rotate, and then move it in, and then rotate, and then move it like this, and then scale it down. Scale it up, and then just match it correctly. There we go. And now we just need to... I can do it using the magnet. I don't really use snap all that often. And by all that often I mean nearly at all. But we select face. Will this work? It'll be on the inside, that is true. Oh no. Oh no no no. Face project. Faces? No, it will still be on the inside, that's wrong. Nah, screw it, we're doing it with puff. Oh, Bezier? No, I'd rather do it with puff. I like the puff curve. So like this. Then we just move it over to the right spot, where we'll begin its journey, right here, and then we just move it around, and around, and around. Just like that. And then back. Sick! These two can go a bit more in front. And then I get lost in this program. So many buttons. Most of them are on the keyboards, you know. It doesn't really matter. Resize this, resize this. Actually, maybe resize it a bit larger. Sick. Array. Crank that bad boy up. 0 on X, 1 on Y. Okay, crank it a bit less maybe, and then add modifier, deform, curve, curve. Select this one because that's the only curve. Then how about we lower the size a fair bit, and then some more, and then some even more, and then we move it to the spot, rotate it by, wait no. Okay, so this isn't working. I have to move it to these coordinates. go, and then rotate negative 90 degrees. Sick! And then rotate 90 degrees. Not what I meant at all. I meant 90 degrees, then we can scale it down a bit and some more, and then just fix the path up because it's all on the same height, which it should not be. Make a Celeste stream when? Oh, I don't know. I know. I suppose when do you want? From what I've seen, you all don't actually enjoy gaming streams all that much. Unless I'm wrong. Up, down, left, right, A, B. Sick. There? That looks wrong, because right here is going off into the sky, which it knows it shouldn't. Alright. Lower discount. And wrap it a bit more tight around the thing. Yeah, we'll go through my ear, but who cares? Who needs them anyway? There! That looks good-ish, I would say. And I suppose a sphere. Just pop it right onto the eyeball. I'm pretty sure back then they didn't have ears. Yeah, that's true. That's a true fact. That's actually the government is trying to hide it from you. That's a true fact. Mainstream archaeologists don't want you to know. Alright. And now we just set this to be pitch black. With roughness higher and metallic higher. Material 20. Sick. Pirate! Pirate, make it! Oh, that's a good one. Ah, we do need a parrot. We do need a parrot. Let me check. Let me see what I can do. Let me see what I can do about the parrot. Royalty free, no AI? That's precisely what I'm looking for. Well, I wouldn't actually care about no AI, because I won't be using it for AI, but royalty free? I can even download! Okay. Hold on, I need to open up my models folder. almost there, almost ready. Practically done. What makes do you make it active and passive? How do you mean? Alright, there we go. It's a freaking parrot! Look at the... It's a parrot! Okay, so I can either have it on my shoulder, or we can have it like attached to the side, because it is a wooden statue. Let's see which looks better. What makes switch states? Oh, it's me talking. When I chat. Right, there we go. That's... It's a parrot! Why is it transparent? Okay, I have to fix this up because this is just wrong. Principal BSDF, there we go. Plug this bad boy in. Oh, I did this for wood. Whoops. No, I meant Principal BSDF. There we go, that's a parrot. Freaking parrot. Have there only be the parrot talking, no make it. That's a phenomenal idea. Oh, that is a genius idea. That's a genius idea. We're gonna go in and we're gonna delete all of the keyframes. Wait, no. No, make it will be always in this position. There we go. Delete all keyframes. And then it'll only be the parrot moving. Oh, that is a phenomenal idea. Alright, so we'll basically have the parrot leaned forward. So this will be the... and then leaned backwards. Honestly, this is already kind of done. That's easy. 3D modeling is really not that difficult. Now we have a passive make it and an active one. There, now it's time to render and yeah, we're done. Beak open. I can try. It's not gonna be easy. It's really not gonna be easy. But I'll try. In order to open the beak, it's all part of the same thing, which means I basically need to select the beak. I could do it with... okay, I have one smart idea on how to do it. Which is with armature. It's my only intelligent idea on how to tackle this problem. But then we would basically need to still somehow get them separate. That is a pickle. We'll cross that bridge when we get to it. I haven't done armature in a while too. So basically we'll have the head. We'll have the top beak, bottom beak. And now we'll basically need to somehow do it in a way so that the bottom geometry, vertex groups I think, easy part, I'm talking animation tutorial will make it. I mean, this is a very annoying one, I'm not gonna lie. Oh, hell yeah, that's actually pretty good. Some pretty convenient geometry we got there. Relatively convenient, because now this is happening. Okay, it's fine. We can just select this and then deselect the front one. Right? Can we? We can. There. That should be just the... Don't give me a second. I almost spilled water everywhere again. Oh, jeez. Back. Flashback. Something in my office smells like poison. You know how when you have something poisonous, it has like this distinct smell? Where your body is like, no, I ain't supposed to be smelling that. Yeah, that's basically what I smell. It's not like a bad smell in the traditional sense. It just smells like poison. Why am I doing it like this? I can just do it like this. There we go. It's much easier. I have been doing a fair bit of chemistry, but I don't think that much, have I? Okay, so this will be better. There we go. Can I only add this vertex group? Now we have this group, which is the bottom beak. And then the top beak, which will be this, basically. Without the bottom beak. Isn't that just the gosh dandy sick? This. No, this. There we go. And then a sign. And now we have the top beak too. And now we just need to... somehow parent the bottom beak to the bottom beak bone. And the top beak to the top beak bone. No idea how. Well, one would actually expect the chemist room to smell like that. That's the problem. I haven't done that much chemistry. It smells like ethanol a bit, but like way stronger. It's hard to distinguish what it exactly smells like because it just hurts. How do I parent a vertex group to a bone? No, with automatic weights it won't work. There's no way. There's no way it works. This beak is gonna pull this one, right? Well, that's even worse actually. How? What did you even parent? My lord. What did you parent? Automatic weights. Wait. Armature deform, yes. With failing solution for one or more bones. Why? should be simple. Oh, okay. I can do it the dumb way, but I don't want to do it the dumb way. I could basically just separate this and then separate this and just do it, you know. Do it this way. We're just Hiya! Ha! Yeah, the top one has to stay. The top one has to stay, but the bottom one. Okay, so here we have the non-talking one. Here we have the parrot which just shuts up. There we go. It's gonna look like this. And then right here is gonna open its beak like this, which is precisely how it works. Wait, actually the movement might be... we can do the movement a bit more subtle now that we have this model. It's the dumbest thing. No, I mean, I wish I could add bones, but I couldn't. I'm not good with armature deform this way. I mean, I haven't made the armature for this make it. That is 100% made by yours truly. Not the model, the armature. But I don't get it, still. Oh, oops, no, this is the active. And then this is the passive. Squawk it! That's pretty good one. Hide the flame! I know, maybe it could be literal 1 pH acid. Oh no, that acid has like 0 pH. I feel like it hangs in between 0 and 1. No, it doesn't smell like that. No. Sulfuric acid isn't, as far as I'm aware, sulfuric acid isn't that poisonous, it's just corrosive. It burns, it doesn't poison. Well, I guess it depends on your definition of a poison. But you know, ethanol, for example, right? That's a poison. It doesn't just burn your skin or something, it actually goes into your system and then messes things up in a complex way. Passive. Yes. Alright, time to switch up the make it, everyone. Give me a second. I think it technically is poisonous. Yeah, that's what I meant, but it depends on what your definition of a poison is. Oh, I'm so glad to finally get rid of this make it, honestly. Oh, I am so glad to finally get rid of this make it. There we go! There! Life on the open seas! Me mateys! How are you all doing? Fuck, it's the parrot talking. It's so much better. Yes! Oh, that's phenomenal. Oh, it only burns off your skin. Okay, make it. No need to worry. It's only highly corrosive. Well, I think that's the difference though, because like if something really is highly corrosive, then you can feel it. You can tell. All right, listen. Like if you poison yourself, you always ask yourself the question of, oh, am I poisoned? If you have concentrated sulfuric acid on your skin, you're not gonna be questioning. You're like, oh yeah, that is concentrated sulfuric acid. I can tell. Oh, that's a phenomenal. That's a pretty good one. I have no clue. I'm not a chemist. Neither am I. In 40 minutes, actually. We finished this in 40 minutes. Wowee. I really do be speedrunning those nowadays. Well, so what shall we do for the rest of the stream? Any ideas? Ugh. What are we doing now? Precisely my question. Celeste stream. I'll have to download it. What even is Celeste? I've seen it only once. Fortnite Among Us. Ah, that would be a good one. That's it. I wish. Unfortunately, not everyone's as highly intellectual as you. Do I even have Celeste? I don't. I thought I had it. Whoops. I don't think I have it then. Platformer, very intense. Define very intense. We could play. Oh, I don't have Doom Eternal installed. Unbelievable. I was about to say that if we want very intense, I could play Doom Eternal, but never mind, I can't. We're gonna do a multiplayer game. I'm interested in joining. Flame, have you ever played the finals? I know we can tell. I kinda like that game. A fair bit. Would be fair to say. It's not that intense, just some things chase you. So time limited. I see. Man, I'm a new bit of Psychopaths. Yeah, I got the memo. I have not. Well, what are you waiting for? I really like the finals. It might be my favorite online game. As in the strictly online, because Satisfactory is still, you know, top spot. Oh, I can tell. How could you tell? I practically never play it on stream. There. Oh, this pirate. I really like this make it. Hold on. Let me message my patrons on the Patreon only channel on Discord. Patreon, make it Patreon on Patreon. Make it. Add. Let me message them. Everyone. Hold on. Because I'm proud of them. I'm proud of them for picking a good make it for this. I'm proud of your. And then just passive and active one. There we go. I wish I could run the finals. Yeah, I mean it is graphically intensive. This is gonna be the first final stream. Yeah, I think something like that, right? I think this might be one of my first final streams. I think I will be a great politician. Mate, that's such a low bar. Give yourself a higher bar. I think it could be a great politician. I'm yet to meet one person that wouldn't be. Alright. So shall we play the finals? I really want to play the finals. No, screw it, we're playing the finals. I think I would be great hypocrite. High bar job. There, we're playing the finals. It's decided. It's decided. Businessman and woman. Yeah, that's better. I guess I could try it out. I would really recommend. I know we can tell, but I like that game. Today I'll have a pretty long day after the stream. Because, well, a pretty long day. I have to basically. No, I can't spoil it. I can't really say what I'm gonna be doing without spoiling what I'm gonna be doing. Damn it. It's just a long day. The point is, I'll be working on no videos, and so I want to relax beforehand. No, it's 20 some gigs. Oh, do you not have it, or do you mean like time? Because if it's time you need, I can just play 1 or 2 ranked games in the meantime. I really like the finals. Is the script for the heat vid done? Oh no! For that we need a scripting stream, and that we're gonna do tomorrow with Flame because today Flame can't do a scripting stream. Okay. Okay. Today because you see it's Monday and I don't have space on my PC unfortunately. Ah, damn it. Well, Flame, I would re-welcome you on the stream tomorrow for the scripting stream. Well, I can today. I just been, no, you can't today. No. You see, it's Monday. And so you are tired, and you know it would be very. I would feel awful just forcing you to script a video with me, you know, on the Monday. After like you just finished your exams, so that. Fine, I'll play one game, we can do it. You talked me into it. Fine. I can't say no to you. Alright, let me just pop a vitamin pill. It's pretty outstanding, like how many things you can just get off pills. Of course, I'm getting my caffeine, my vitamins, my everything. Oh, daddies. I mean, Teammates, play the heavy. I'm light. I'm teammates. Hi. All right. I didn't talk to you into anything. I wasn't even the one who suggested it. Fine. We can do a scripting stream. Fine, I get. All right. Just give me like 10 to 15 minutes, to 20, to 25, depending on how well it goes. How well do you know your photons, Flame? Question mark there. Hide. I don't know how to ping hello. I'm not ping hello. Do you hear the hissing sound in the background? That's my vitamins. I'm staying healthy. I'm taking 5 daily doses a day. How well do I know my photons? Pretty well. Well, then that's gonna be actually splendid, because photons is like the least in your area thing we'll be talking about. The rest will be very in your area, because the rest will be just electrons. And give me, no, give me. I can deliver it quicker. You can give me the cash. No, can I? No, can I has? Can I has the car? Can I? Sorry about that. More just the stuff that involves them. That's actually even better. I'm going to the about for myself. That's actually even better, because that's what I need. I'm gonna go in depth about the photons themselves, because that sounds like something I'll be interested in, and I need a problem with the things which affect, which they're involved in. Eat rocks. Very much depends on the rocks. That is true. I mean, you can eat anything. Just there are some things which you can only eat once. Okay. What the heck is a photon? A photon is a, as far as I'm aware, elementary particle of energy. Like the purest... No, well, not quite the elementary particle of energy, only like the most efficient energy transmitter. Am I making sense? I feel like that's a good enough definition. Because, for example, with electrons or with matter in general, you have mass, which really screws with energy, but photons don't have mass, so you can just go wild. Yeah, so photons are light, and they are particles and waves. Got him! Yeah! He, yeah. I mean, there must be some type of uranium that's safe to eat. I don't think so, actually. Call me crazy if you want. Isn't all uranium radioactive? I mean, with isotopes, you don't usually get less radioactive. So if, you know, normal uranium is bad for you, isotopes aren't gonna be much better. And ions, I don't think ions would be better either. Photons will be like light classifying. Precisely. That's exactly what it is. We're going really well. We're doing really well as a team, by the way. I know y'all probably don't care, but we're doing really well as a team. As you can, I don't mind the... No, hold on. I want to get a sip of them. Wait, where's my glasses? Oh, that's where my glasses. I love this 3D model of the Make It. It's phenomenal. Can you tell us? I'm hungry for uranium. Flame, you have... Yeah, would you mind giving us a recommendation of which uranium to eat? And do keep in mind that you will be held liable. The Kingfish are back and ready to avenge that team wipe. Okay, I know where the enemies are. No. One contestant
doesn't seem to like rigid structures.
I think U234 isn't radioactive. Or it is, but a safe amount. But I think it's less chemical toxicity. Oh yeah, wait, actually with isotopes you can get less radioactive. I'm an idiot. I forgot the ratio of neutrons
The competition is
goes up.
getting fierce.
No time to run and get snacks, viewers.
Why didn't any of y'all correct me on this? How? I blame you. That's the worst tasting one. Flame, but we don't. I don't like that flavor. Whoa, is that a rocket in my spine, or are you just excited to see me? Okay, well, that's not good. I'm the last person on our team.
Going for the revive. The Kingfisher opening vault 4.
Yeah, okay, well, then there we go. Simple as it could be.
Going for the revive. The Kingfish grabbed a cash box.
Alright. Never mind, I was wrong, I just googled it.
The Kingfish.
The thing's flame chemical toxicity just adds more flavor. I mean, technically you're not wrong. If you don't mean like good flavor, only flavor, then technically you're not wrong with this. Because chemical toxicity, on average, is more flavorful. Because it like stings your your taste receptors more.
Creating a smoke screen. A long-awaited return to yes. Smoke grenade out.
I think I can do it. Is that a hammer? That is a hammer. Almost.
Our contestants are projecting
Most chemical toxicity is just bitter.
in the arena.
Yeah, but almost all. Most is just bitter, but almost all is just intense.
I can practically hear the detonations from here.
Wow, I wonder if there's like an evolutionary reason for why we would associate toxicity with bad flavors. That is crazy. I wonder that. Wow, I wonder if there's a reason.
Continue to deliver surprises.
Oh, we're just here, actually.
Two cash outs in a row.
That's where I died. Vault 5 is right there.
There's a new vault to fight for in the arena.
Rat poison isn't that bad. Rat poison isn't that bad is an opinion. It's a very opinion. There was a person behind you, wasn't there? I wonder why people like the feeling of defense mechanisms from plants stop us from being eaten spicy. Or spicy, or maybe cool, or maybe... Wait, what else was there? Bitter. Bitter, spicy, cool, all of those are just plants trying to... Well, not really us. They're stopping the insects, and they are succeeding. I don't think they care that much about animals eating them.
Need to stay light on their feet to avoid attracting some unwanted attention as our orbital laser
Well, some of them.
is
I mean, the
still
one with,
active.
you know, the seeds.
Sweet! The Kingfish just netted a cash out. Vault 6
Relocating.
Well, I meant 5, but...
A new vault. Our
Close enough.
contestants better not leave that unattended for too long. The Kingfisher.
Oh, that's a grenade.
The Boundless
30
are
seconds.
strong-arming a vault.
I ain't risking it. I'm going for the... Where's the vault? Where it is?
Which team will try?
Left 20 seconds. Okay. Got delivered. Sick, neat, fantastic, lovely. Don't make sure that it gets delivered. Okay. Plants definitely feel human anger when I eat their fruit. I mean, if it grows resistant to scorpion poison, it will taste great. I don't think that's how it works. I really don't think that's how it works.
Go for cash out A.
Right on. The
We have
balance
30 seconds. Is this doable? Technically, it is. Maybe, kind of. Yes. Yes, it is.
Vanish bomb out. Fantastic steal by the shock and awe.
Please tell me that was enough of a mess to make my team win. No oh. No oh oh.
Taking damage.
The shock and awe dropped a bombshell on the match, taking the victory. Their competition will need to avoid standing in awe of them next round.
Interesting thing about tastes is that some of our tastes are extremely specific to individual ions or molecules, and some are super broad like bitterness. No, no. Alright, fine. Let's go for it. Elementary particles, I guess. Let's do it. Fine, let's script the video. If that's what you all want, then fine. So. Yeah. Yes. Flame wanna join?
Jump scare.
Oh my goodness, I'm terrified. Hi there. Oh no, I now have to be
Hello.
small now. People won't see the bear talking. I'm so proud of that. The things I do for you. Alright. So, the high flame, how is your day going?
Hello.
I haven't heard from you in such a long time.
It's been alright. I had an exam. I finished my uni year.
Now I can exploit you more. I mean, that's good.
Yep.
Great for you, yeah.
Yeah, yeah.
Also, an internship, if I remember correctly.
Yeah, in a couple weeks, yeah.
That's also
So I'm
really nice.
staying on campus for like another 2 months just to do the research internship.
But it must be nice staying on campus to just, you know, knowing that the year is kind of behind
Yeah.
you.
Yeah, it's chill, but I would rather be in London, you know, mainly because of my mum's cooking, I think.
Oh, hold on. Hassan just asked, make it, are you a university student or have you done university? If not, how do you acquire so much academic knowledge and skill? The fact is, I didn't go to university nor acquire this much academic knowledge. It's not difficult. Most of these things aren't difficult. And those that are difficult, I just don't cover them. That's why Flame is here. So that, you know, I can actually gloss over all the actually difficult ones. For those who do not know, although you should know by now, Flame is quantum chemist would be the best way to describe it, I think. I don't know exactly.
I just call myself a chemistry student.
Or just a chemistry student. Well, I suppose a chemist also.
I mean, I guess I am a chemist because I'm about to get paid to do research.
Hell yeah! Professional chemist! Hell yeah!
I don't know, does an internship count as professional?
Yeah, that's actually... Well, professional just means that if you get paid,
I guess,
then
yeah, it
you
just
are
means
a
you're getting
professional.
paid, yeah.
That's why there's so many things which I'm, like, technically a professional in. It's quite fun. I'm a professional YouTuber. I'm a professional streamer. I'm a professional finals player.
Yep.
Technically. Okay, so here's the thing. I've got this video, right? Straight to the point.
Mhm.
About heat.
Yeah, it's a pretty cool thing.
Yeah, and it will actually be divided into two parts. The second part will be just thermodynamics, explaining, like, you know, an introduction to thermodynamics. And the
Yep.
first part will be more about the concept of temperature. And basically, I mostly want to focus on temperature as just kind of energy, so thermal energy. And in
Okay.
order to make my point, I basically want to use light, heat, well, not heat, light, temperature, and charge. So, well, electrons mostly, I suppose, more than charge. Has like 3 different examples of mediums of energy. And so that's actually kind of it. I don't have a lot going on with this. But what I would need is, first of all, an example of like switching in between them. With,
Yeah.
for example, phosphorescence. I always forget the exact name.
There's fluorescence and phosphorescence.
Phosphorescence is the brightness one, right?
Well, they're both like they're both absorbing light and re-emitting it, but fluorescence is like it happens instantly, and
phosphorescence
phosphorescence
is-
is it happens after a delay.
Yeah. So I feel like
So like when something's like glow in the dark, that's phosphorescent because it absorbs light and then emits it
I
later.
think phosphorescence is just a bit more interesting, honestly. I know they're very
Yeah,
similar.
I mean they're both actually kind of the same.
same
It's just
thing, except-
phosphorescence. It does an extra transition, and that transition is takes more time.
Oh, you just glitched out of existence.
Oh.
Discord is really not doing you. well. But
Is
I
it
made most of
Discord? Is it the connection?
I think it's Discord. It sounds like a
Okay.
Discord.
It says I've
mixtape.
got 10 ping, but I don't know. I was just saying they're both really similar, but phosphorescence takes more time because it involves a spin forbidden transition in the middle.
Or maybe
And if a transition's forbidden, it takes more time.
forbidden. I always love the fact that's like actual scientific term.
Yeah.
Forbidden. Okay, so actually maybe I should do 4 kinds of energy.
I do have like lecture slides on statistical thermodynamics and photochemistry. Like 2 different topics. But statistical thermodynamics is like very advanced thermodynamics, and it's just I mean, you know, it sounds like what it is basically.
I don't like thermodynamics, don't go lie. I mean,
Yeah, no, I
so
don't like
far,
it.
all I'll have to do for thermodynamics is make this equation, explain this equation without using math. That's my goal.
Okay.
I think it's possible. Be-
I haven't seen this equation. Is this like a different form of something? I
no,
might
this is
know.
like this is what you get when you solve the heat transfer equation for copper metal, where the one end is 100 degrees Celsius, the rest is at 0, and with all the things defined.
Oh,
You just,
okay.
when you solve it, you just get this. So far, I kind of have it. I kind of have an idea because I'm pretty certain. Okay, translating math to human is not easy. But like, this is simple. This is just a change in temperature in relation to change of time, which is equal to D is literally defined in the textbook which I used, and then change in and then the acceleration of temperature in relation to position. So yeah, I can say it with words, but this is a bit more difficult because it's just a method of solving them. Can't wait for this video to make it. Neither can I. Okay, hold on. I'm having trouble collecting my thoughts. I should drink something. I can't do this sober. Okay. Be responsible, kids. Don't do thermodynamics sober. Kinds of energy. I'll do temperature, electrons, then light, and then chemical. And then transitions between them. That'll be the next one. Transitioning between them. And right here, for example, light to electrons. That's such a dumb way to put it, but that would be fluorescence and phosphorescence.
It's more than just those two.
Yeah, but those two I'm gonna use an example because I'm not gonna do.
Well, those
I guess
two are like
photoelectric
it goes.
wouldn't also be.
Yeah, those two are like light goes to electrons, and then the electrons go back to light.
Yeah, so that's why I like as a transition, right? I think
Yeah,
it's
yeah.
nice enough.
And they're quite cool. I think it's a cool thing that people should understand because it's like it's one of those things where it's like, why don't people question it when you like have a material that's glow in the dark and you can just make it glow
Honestly,
without light?
even I feel like glow in the dark. That's mysterious a bit to most people, but like reflections, I don't think you need to go to glow in the dark. Reflections, because if you think
I mean, reflections are like easy. It's like easy to understand on the surface level.
on the
which
surface
is
level,
just,
yeah,
like,
but
the
if you
light is
get a little bit
reflecting.
in depth, it doesn't make sense, because
Yeah.
when photons get into the atom, right? When photons hit the atom, they don't really reflect in the classical mechanical sense, because if they try to do it in the classical mechanical sense, they just wouldn't hit anything.
Yeah.
And so that's why I really would like to include fluorescence in here, because I'm not gonna lie, I'm pretty certain I'm stealing it from a video. It was, I don't remember who made that video, but it was basically a video about why things are transparent. And when you explain why
okay.
some things are transparent, then the main question you get then is, hold on, if that's why things are transparent, then why isn't everything transparent? Because for
Yeah,
transparency, it just
yeah.
makes sense. The photon is just going through an atom, and yeah, that's kind of obvious. Why am I preaching about this to a chemist? That doesn't feel right. Okay, so that's what I kind of get. I still we'll get back to this soon. So what else would there be? Electrons to chemical. That's an easy one for me. Electrons to chemical, because that's just electrolysis. I've been doing that a lot recently.
I mean, electrons are chemical. Like that's
Yeah.
like chemical energy is mainly kind of
Chemical, I just
electrons.
mean potential in this case.
Yeah.
Which
It's so weird. I
all of
haven't
these-
heard I haven't heard like chemical potential since like school.
I mean,
Even though I've been doing chemistry.
I mean, all of these are not actually the kinds of energy that exist, because like
Yeah.
temperature, like electrons, for example, that's not a kind of energy. You have electrical energy, technically, I suppose. You have thermal energy, but in this case, these aren't kinds of energy. This is more about energy carriers. So chemical will just mean potential energy, as in you can, make a bond which can be then turned into a lower. So in this case, chemical would just mean bonds, as in creation of bonds which can be easily turned into bonds with lower energy. So
I always picture like all these reactions. Have you ever seen one of those diagrams where it's like it shows the energy level over the course of a reaction, and it's like a kind of wave that wobbles about, and it goes up when it's higher energy and down when it's
Never
lower.
have it. Would you have one?
Oh, because this is. Let me just get a quick example. This is like the simplest one. Have you seen that before?
I have not.
Oh, okay. These are the kinds of things I picture, like, with any reaction going on. Because it's like, you start with one thing, and obviously, the reason it ends up as the product is because the product is lower energy. But the reason it doesn't immediately turn to the product by itself
you need
is you need to
activation
give it energy to go in that transition state.
Wait, does it? Does the product always have to have less energy? Can't you also?
Well, if you think about it, if you think as you heat it up, right, it reaches the top of that hill at the transition state, and then it can go back down either way. But it's gonna prefer going to the lower energy one,
But what about
So
like
that's why.
electrolyzing
So
water?
yeah,
for
the product
example?
is.
Because if you electrolyze
Uh,
water, you end up with oxygen and hydrogen gas.
Yeah, it kind of it gets wonky with other stuff.
Oh, so that's for
Um,
heat.
What do you mean?
Because
This diagram?
you said heat up. Uh,
Oh, well, that's what I mean when I say providing activation energy, but it doesn't. I don't think it has to be heat. But electrolysis is different because electrolysis you're like forcing electrons into different places, and so it doesn't obey the rules of this kind of diagram.
I really like this way of putting it. You're just forcing electrons in there.
I mean, yeah, you're forcing electrons around.
You're gonna bond with this atom and you're gonna fucking like it. There's an
Yeah.
unlimited life. That's new for me. There are ads. Oh yeah. Oh yeah. Monetized. I keep forgetting. I keep forgetting that's a thing. In my mind, it's 500 subscribers. Okay, so chemical in this case, I mean, I will explain all of this right here. I will also mention that these aren't the actual kinds of energy that exist. But chemical in this case, I will just mean potential. Potential in
Yeah, I
bonds.
mean it's fine. Yeah.
And so electrolysis chemical would just mean making higher energy bonds. Light to electrons, fluorescence, phosphorescence. I really like that example. I could go with the photoelectric effect, but I feel like photoelectric effect is cool if you're already getting into quantum mechanics. But fluorescence is something. Fluorescence is still amazing to me, and
Yeah.
even though it's such an everyday thing. Okay, saying it's everyday is a huge understatement. It's reflections.
You have to be careful. Are reflections for? I don't think reflections are. Fluorescence is different because in fluorescence you like lose energy before it re-emits the light. Let me check.
Oh no, it's like oh no. That's why you see, kids. That's why you all should also always find yourself a.
Yeah, no, fluorescence
Chemistry,
isn't
yeah, 'cause-
isn't reflections because in reflections I don't think they're absorbed by the actual molecule.
Okay.
In
so,
fluorescence, the molecule absorbs it, and then the electron like changes state, changes energy, and then the electron re-emits the light to drop back down in energy.
yeah, see, that's kids. That's why you should all get a chemistry friend in case you wanna say some random BS on the internet. Make sure you're not spreading misinformation. Nuclear fission, fusion 2, everyday thing 2 more times a day. But yeah. Hi, Detector, by the way. Hi, welcome. You wanna join in? Oh, okay, we've never done a triple stream before. All right.
I've got a phosphorescent ring actually, and I have a UV torch just because. And so whenever I'm bored, I just light up my ring and it glows green for like an hour.
I am one phone call away from like a phosphorescent 3D printing material, so I might also use that. Hi, Detector. How you doing?
Good. How are you doing?
Oh, really
Hello.
well. No, Tefta, Flame,
Yeah.
Tefta. Yeah, I mean, you've seen each other. I don't know
We've
why I don't
spoken.
feel
We've
the need-
spoken. Yeah.
Yeah, I don't know why I feel the need to like introduce.
I'm also working in the background, so
Oh, so
you'll
this is very
probably hear me type.
very productive kind of live
No,
stream.
I'm doing nothing.
Oh yeah, well, listen, considering like how many views I get, I am also doing nothing, so you know. Okay, what else could there be? Because in the last one will just be heat, as in heat as a transfer. So heat, and right here will be just heat turning to all of them. Oh, here heat influencing all of them. So for example, with light, that's an easy one. So so like light, it'd be the fact that when you shine light at something, it can heat up, and when things get hot enough, when some things get hot enough, they glow. Of all things, I don't know, I haven't done
Yeah.
the research for it yet.
I remember like black body radiation from school, but I can't remember too much about it.
Nothing from school. Those. Nothing there. I'm a YouTuber.
It's stuff like as things heat up, they emit light from low wavelengths first, and then as you heat them up more, the wavelength goes higher and higher and higher. So that's why like first when something's hot, you can see it with like infrared because it's low wavelength, Sorry, low frequency. I said, yeah, sorry, I meant frequency.
I mean,
But
wait.
then
wait.
as it gets hot, it turns red, and then it turns white because you're then going from just red to all light, and so it becomes white.
Makes sense. I mean, wavelength frequency, yeah.
They also made ice machines in the middle of the desert using, I think, infrared radiation.
Ooh.
How?
Back in like
How
hundreds
does
of
that
years
work?
ago.
What the hell?
Yeah, so what they
That's
did is they
crazy.
created like a clay wall area that was like thermally insulated and had like an inch or two of water, and literally the top end was open and pointed to space, and because it radiated the heat out and the water was shallow, it would actually freeze even though the temperature outside was above freezing. So
That's
that kind
crazy.
of baffled. Yeah, you should look it up. Like, don't take my word for it. It's super chill. Funny.
That's cool. Okay. I immediately
Did you
regret
guys
accepting
both
that.
just make puns?
No, what?
One-
We
okay,
would
okay.
never. Okay.
It's a way of life. It's a way of existence.
Light to electrons, electron. Is there anything else that would be like easy enough to? Because the last one would be just heat and wait, heat with chemical. When it comes to chemical reactions, I know that heat is a great. Oh, catalyst is it called? Damn it, cut something.
I guess.
speeds up reactions?
Can you call it a catalyst?
For most
I mean,
reactions.
I guess. Yeah, I guess you call it a catalyst.
Yeah. So
Yeah.
I know
for
that
the reason
one.
of that graph I gave you.
Yeah, so that one's kind of obvious. But do you recall any like? Do you know any interesting things when it goes to reacting things with heat?
I mean, there's the whole oh, what's the word? I've forgotten the word. My brain's blanked on the word. Some reactions require heat and like absorb it over the course of the reaction, and some reactions give out heat. So it's like some
Exothermic,
Endothermic
reactions will-
versus exothermic.
Yeah, that's it. Endo and yeah. Thank you. Yeah, some reactions you do them, and the like flask you're using gets colder over the course of reaction because it's absorbing heat from its surroundings.
Oh, heat is a catalyst. Explain. Well, because them particles be moving quick, so they be whatever they're supposed to do, they be doing that quicker. Hi, welcome. I'm Megan.
was
I'm a
that-
scientist. Technically.
There was that famous test. It's talked about in memes or in like Reddit lore, where at the end of a physics test they asked if hell was endothermic or exothermic, and like you can read the student's response.
Wait, that's a good question, actually.
And they actually defined hell as either exothermic or endothermic. It was like an extra credit problem on a college test. I'll try to find the link and post it
I
in
guess you
Discord.
could-
Was
I
that
think
like
you
one of
can-
those open-ended questions where if you just argue it well enough, you get the marks?
Yeah, because I feel like you could argue for both.
I think so.
Yeah, you could argue for both. Like, it is releasing heat, but also,
It was a physics exam too,
Also,
so it's kind of makes you
would
think.
hell
Yeah.
be a closed system?
I think that just depends on the definition.
People go into it.
Yeah, people go into
Yeah,
it, but
well-
the thing is, the main reason for why some things are spiritual is because they
California.
don't obey the classical laws of physics, and because of that, you could have souls only going into it without anything actually, like any particles or any energy escaping. Would that then be a closed system? That's for the philosophers to wonder for the future. We'll leave that. We're asking the real questions. We're answering the questions they are afraid to ask.
I will say, in terms of
Um,
heat with reactions, there's two factors. One is that you give particles energy to like bump around and meet each other more, and then the other one is you've given them more energy for when they actually do collide to then do a reaction.
Oh, so basically, if they need to collide, then the heat both makes them collide more often and stronger.
Yeah, I think the strength of the collision gives the reaction energy. I think
That
so,
doesn't make
yeah.
sense, you know, because that certainly would make sense, like kinetic.
Yeah. It's weird because in chemistry we kind of ignore the fact that it's like molecules bumping into each other, but then in like some really specific topics about like reaction kinetics, that's what it's all about. That's like the whole thing. It's just how many times are these bumping into each other and how do we define that and all of that. It's just loads of maths.
Okay, now I'm gonna Oh wait, I think I can do one more, which would be really cool. I think I can do one more, which you might really like, Flame. It's gonna be a bit of a stretch, but I feel like you'd really like that one. Right here, we'd have light to electrons, so basically fluorescence and phosphorescence. Electrons to chemical, as in electrolysis, and then I could do light, or rather light to chemical to light, technically, which would be colors. Technically,
Colors are it's kind of a similar thing to the first half of phosphorescence and fluorescence, because it's like everything has like these different states that the electron can be in, and when it absorbs light, the electron can jump a certain gap, and that gap is specific, so it absorbs a specific wavelength of light. And in jumping that gap, it's then absorbed light, and so that means it doesn't reflect all the light because it's absorbed sun. So that's what makes the color. So it's kind of a similar thing to fluorescence and phosphorescence, because in those, they still absorb light at a specific wavelength to jump that gap. It's just that then the electron does some stuff and then drops down the gap again and re-emits the photon. Well, it emits a different photon, different wavelength.
so right here it's basically photon gets absorbed, a different photon gets emitted, and right here the same photon just gets reflected. Kind of.
In colors, it's getting absorbed, and that's it. Whereas in fluorescence and phosphorescence, it gets absorbed, and then the electron emits sun again.
Okay. Wait, hold on. When photon gets absorbed in colors, actually, like if you have a red thing and you shine some blue light at it, right?
Yeah.
What's happening? The electrons just stay excited?
I think it just transfers into heat. I think it
that
excites the
makes sense,
electron, and then
actually.
it just kind of, through vibrational relaxation, it just releases the heat elsewhere.
Hi,
I'm not entirely
by
sure.
the way. Hi. Colors is just frequency now, ain't it? Well, depends. Like, if you mean just light, then yes, it is. Okay then. So, I'm gonna need you to repeat. That's my hand, by the way. I'm gonna need you to repeat the whole course. Not the whole, not the course you got, only the course you gave me a couple streams back about fluorescence and phosphorescence. Cause
Okay,
I can
let me get this
decently
up.
well. I have a decently well idea, but I'm gonna make up stuff if I don't get it fact checked. I'm just gonna spread misinformation. That's how I guilt people into being an expert for me.
Yeah,
I just tell them I'm gonna spread.
you're gonna spread misinformation again.
Yeah, again, yeah.
All right, I had to tease you. Yeah.
I have done it in the past. I can't pinpoint anything too major because whenever I'm about to make a large claim, I do the coward's move and say mostly or as an oversimplification or stuff like these. But yeah, there's something.
What was that thing that? Because your video got removed for misinformation.
Oh
right?
yeah, medical misinformation was even funnier.
Yeah.
Oh, that video. Oh, that's
That's what I was referring to.
such a
Yeah.
phenomenal story though, because making a video about cancer, getting it fact checked by a med student who went through cancer, who got 2 cancers, survived them both, fact checking my video, and then YouTube removing that video for medical misinformation. That's just wow. To be fair, I did start the video by joking that like you can cure cancer with lead and you know various poisons and stuff, or by setting yourself on fire. I also mentioned that that's a solid way to, you know, get rid of cancer. Which technically it's not wrong.
I'm guessing that. Yeah, I'm pretty sure that's why they.
Yeah, I think that's right.
flagged it.
Why would they remove the video? It's true though. That's what I'm saying. That wasn't misinformation. that was just facts. Listen, lead Okay, I don't know if lead exactly. I have to go a bit more extreme than lead.
Should say that censorship is the cancer of our society.
Oh hell yeah! I actually do believe
I was
that.
just trying to be funny there.
Actually, I mean, I appreciate the
Probably.
pun, but I really do believe that. How's it going? Hi there, Ali. You won't believe. You're just... Whoa!
The
What a
timing on that.
coincidence. Ali, how's it going? You want to join on stream? We're having a party. Oh, we could.
I can
if
screen
Ali,
share this, by the way.
if Ali was to join in, we could make some outstanding biotech as a group. Well, I would be more of a mascot, but hold on, let me. May I share it on stream?
Yep.
I always prefer to. Remember, kids, consent is hot. Well, not kids, maybe. Never mind.
Hey, Allie.
Is that Flame? Yeah, it's Flame. Hi, I'm familiar.
Hello.
voice. Flame has been on so many live streams at this point. I feel like Flame might have been on more live streams than you, actually, Ali. That's funny
I've only
enough.
been here for like a few weeks.
I mean, Ali is a lot in chat, but I feel like Ali's only been on a couple of actual streams. That's a bit blasphemous. You haven't been on a couple of weeks, but you made an impact. I get
Oh, here's some
chemistry now.
molecular orbital theory.
Oh hell yeah! I finally get it. Oh, that's phenomenal.
Can you tell what these orbitals are?
And wait, hold on. N2. Okay, so pi star. That's an anti-bonding, right?
Yeah.
That's anti-bonding pi orbital. The arrow confuses me a fair bit.
It's saying an electron goes from this orbital into this orbital.
I mean, they are spread about, so that's anti-bonding. Certainly. Okay, I already said that. I'm just trying to. I'm just playing for time.
In here, there's multiple
Is it-
different orbitals on this picture.
Is it? It's not hybridization, is it? Wait, oxygen, methanol, methanol. I get the ethene one. Can't you ask me about the ethene one? Why?
Go on then.
That's an easy one.
That's an easy one, yeah.
That's a pi one. I get that one.
Yeah, so it goes from pi to pi antibonding, yeah.
Oh my goodness! Wait, what is happening to oxygen? Is it
I
the
think it
additional
is a hybridized
electrons?
orbital. So you know oxygen has lone pairs on it.
Yes.
These are what the lone pairs like are actually doing in molecular orbital theory. They're like I think they're hybridized orbital. They might just be p orbitals, but I think they're hybridized. And so the electrons just sit in those and kind of don't do anything.
Oh wait, but then why? That's why the arrow is confusing me so much. Because I
Well,
thought
it's saying
those-
that when you excite it, one of those electrons goes into this.
Oh, so basically, when you excite it,
It's antibonding.
it's the anti-bonding gets stronger, so the bond gets weaker. Is that what's happening?
Yeah, this would weaken the bond.
Oh yeah, I'm so smart.
It might even break the bond, but I don't know.
I feel so smart now. Ah, validation.
Have you've seen this kind of notation with the?
I have
the
seen it.
bra
I
and the
don't
cat?
actually. I never bothered to learn what it actually means. I know it's related to superposition, if I don't remember correctly. But I've never bothered to actually learn what it means.
Yeah, I learned it. I learned it like 3 times and forgot it every time.
Yeah.
So don't worry.
I've seen it a lot. I've seen it used, and I've analyzed the places where it's been used. When I did research for the second quantum mechanics video, I'm pretty certain I used one of my sources used this notation, and I got the underlying concept, but I just never bothered to get through the notation. Oh, now I get this one too now. There we go.
Yeah, this is the same thing. These are the hybridized orbitals. I think those are a different shape to. No, it looks like the same shape. I think.
It gives more.
But yeah, you can tell what's going on here now, and this is our conjugated pi system, as we
Oh,
know
yeah.
and love.
Oh yeah.
Here's the Jablonski diagram. Do you remember this?
Yes, I do remember
This
that.
is our phosphorescence and fluorescence. So when it absorbs a photon, so obviously it starts down here, the S0 ground state, and it absorbs a photon, and these arrows represent the kind of different magnitudes of absorption you can have. And obviously, remember, this is quantized, so these are specific frequencies
Yeah.
of light that it can absorb.
So these bars are
And-
the only possible ones.
Yeah. This diagram, you need to. There's no x-axis on this diagram. Everything that's to the right or whatever is just for like visual clarity. So these are all these states in terms of energy. They're all like overlapped on top of each other. So these are over here. But essentially, you absorb your photon, and this is a spin-allowed transition because your spin doesn't change.
No idea what that means.
S and T mean singlet and triplet, and those are names for spin. So singlet means your total spin value is half, and triplet means it's 3/2, I think. Yeah, 3/2. So singlet just means the spin in this state is half. And so you absorb your photon, and you can go up to any of these bars here. And if you go up to one of these up here, then what happens is it does vibrational relaxation, and it kind of trickles back down to here, to this kind of lowest vibrational state
Wait,
of this
Is
singlet one state.
vibrational relaxation it just losing energy as heat? Because
I think so. Vibrational relaxation removes
Wait, hold on.
energy
That's
from
actually
molecule.
it should be easily fact checkable.
I think that is heat.
Relaxation. Caused by internal perturbation of the maximum possible distribution.
Lost by collisions, that sounds like heat to me.
Kinetic modes in the same molecule of the surrounding. Yeah, so it's kinetic. It's so annoying to fact check. Actually, they just really go out
It
of
says
the
it
way
here.
to say
It says it on this
temperature.
slide.
Yeah, okay. So
It
it's-
doesn't say heat, but it says.
Yeah, they
I mean,
really
it,
go
it says hot.
out of their way to to not mention thermal.
Yeah, on this we've said hot, but in quote marks for some reason, and then it says lost by collisions, which
Yeah, on the Wikipedia
can
page
only
also
mean
says
heat.
kinetic energy, so that's heat.
Kinetic is heat most of the time.
Most of them. Oh no.
In
You-
chemistry,
you really,
it's usually heat.
you really do not fill me with confidence because like whenever I ask for I just ask a question to make sure that I understand. You always answer like, yeah, that's
Well, yeah, it's because I don't want to give like a confident answer on
I-
something when there's like edge cases.
I mean, I know why, but it really doesn't fill me with confidence.
no, in this context, yes, you're right. Yeah,
I mean, it's fine. I get it. There's always gonna be this one edge
Yep.
case where, like, I don't know, electron all of a sudden duplicates and creates a positron, and the quantum fluctuations. I get it. I know.
Okay, so you do a vibrational relaxation, you end up in this kind of lowest vibrational state of this spin state.
Mhm.
And from here, you can either emit your photon again, which is fluorescence, or you do what's called intersystem is it intersystem conversion?
Intersystem crossing.
Intersystem crossing. There we go. And this is a spin forbidden transition because your spin state changes from singlet to triplet, and you're not allowed to change spin states in a transition usually. But it's in this case you can do the forbidden thing because there's some like orbital mixing going on, which kind of just means these states aren't purely spin singlet and triplet. They're like they've got a slight mix of other stuff, which means that they're partially not forbidden. Does that make sense? I'm trying to like explain it without going into like all the theory.
Okay,
But
I mean,
these states are like mixed with other things. Basically, they're not pure.
I have only one analogy, which is the exact same analogy I've used before, but it's even more like. Hold on, go over it again. I need one more try.
What about the crossing or the
because
whole
the
thing?
crossing? Because honestly, I get to the left, like the blue side, I get everything perfectly.
Yep.
Because that's just basic electrons,
Yeah.
basically. The red side, I also get it. That's also simple. It's the
Yeah.
wavy arrows that really mess
A bit
with me.
between them. Yeah. well, okay, yeah. So it's this spin. You're changing your spin in this transition. That's all you're doing. You can see even the energy just stays the same.
Yeah, so
the way they've
you
drawn it
can't
here.
go from S2 to T. You can't go from S to T basically, because then you need to change spin, and
Yep.
if you have your spin at 1/2, that means wait, does that mean it's a single electron or
What the state can be spin half with loads of electrons.
Okay, so it doesn't.
It's just
So-
it means you have one unpaired electron.
so you
basically.
can't just like electrons can't have any value in between the discrete ones. In the same way,
Yeah.
they can't just change spin willy-nilly. They can't just change
I
spin
don't think
for no
it's.
reason.
I don't think it's similar to quantization.
No, I mean,
is it
I meant it
forbidden?
as like, it's like one of these rules that electrons just follow.
Yeah,
So just
it's,
like-
it's just a rule.
Yeah, so just like it's a rule, they cannot have any other values than the discrete ones. In the same way, they can't just change spin for no reason.
Yeah,
And
it's like
so-
if this this S and this T state were like purely just this S and this T, then they wouldn't be able to do this transition.
Yeah, so if you have a blue ball, it can't just turn into a red ball without, it's just out of nowhere.
Yeah.
You need to actually paint it red. And in this case, painting it would be an analogy for something that would actually change the spin. This is a stretch, I am fully aware. Trust me.
You're not doing anything to it. I mean,
Yes, in this case, you're not doing
It's-
anything to
yeah.
it, that's why it doesn't make sense. But
Well, what it is that this isn't purely what it looks like in this the way we've written it down. It's like, oh, let me think of an example. I think the example I gave before was like if you're standing on like two sides of a field, right, a football field, and you drew a line between the two halves,
oh, in one place it's fuzz. It's
and for like 2 centimeters in that line, there's a gap, right? And then you said, okay, there's a line between these two halves, so nothing can go across. And that's what we're saying by saying, oh, this is because this is S and this is T, you can't cross. But what we haven't accounted for is that there's actually a gap in that line, and they're not fully two halves, right?
wait,
And that gap means that
And
some
that
of the
is
time it can cross.
precisely that's actually the only thing I don't get is that gap. What
Okay,
is
the,
it?
the gap. Yeah, I mean it gets really complicated.
Okay, go for it. Go
does
for
it
it.
say it
Complicated away.
Well, no, I can't remember all the details either, so I need to just check real quick.
All right, all right. Listen, I'm ready.
It's essentially like you need to think of it as these states. Think of it to do with like mixing orbitals, right? So you know the way, same way we like hybridize, and you go from your individual S and your P's to SP2 or whatever. Essentially, these orbitals mix with some other orbitals, which means that they're not purely singlet.
Okay. Okay.
Because those other orbitals aren't singlet.
Okay. Can I hold on. I can figure this out. So basically
Oh, here we go. We got it here.
mixed singlets, triplet state, vice versa. The triplet wave function.
Spin
is
orbit
informed.
coupling. This is the. Yeah. So this isn't very intuitive.
Hold on, no, hold on. We can make it intuitive. We can make it happen.
Oh, it's the angular momentum stuff. Oh, that's
Angular
okay.
momentum operator as the spin angular momentum. Hold on, what's the difference between angular momentum and spin angular momentum? No, doesn't matter.
Angular momentum isn't related to spin, unless it's the spin angular momentum. Yeah, so I didn't answer that very well. These are our L and our S values from before. Do you remember those?
Yeah.
And so if you remember, the L value doesn't have anything to do with spin,
Yes. Okay.
because
Okay.
the L value is kind of like the shapes of the orbitals and the orientation of them.
It's time dependent on the field generated by nucleus, and K is a constant for the molecule. The effect of the merged singlets character in triplet state and vice versa. So the triplet wave function takes form of psi bullshit, where a zero superscript indicates a pure singlet or a triplet state, and L measures the extent of mixing. Perturbation theory gives lambda even crazier. bullshit. The rate of the Sn to Tn conversion thus depends on the magnitude of the spin-orbit coupling as measured by fast rates, strong spin-orbit coupling.
It's saying,
okay,
it's
so I
saying
get
that the state we're calling triplet is made up of a pure triplet plus a tiny bit of pure singlet. So that this is what we're calling triplet, right? This highlighted bit. This is what the actual pure triplet is, and there's a tiny bit of singlet mixed in. And this lambda dictates the amount of singlet we're mixing in with it.
Okay, I think I have a good analogy which is might work in the video. Okay, I think. All right.
I mean, you really don't need to go into this detail in the video.
Oh, I'm gonna.
This is like, this is third year
Daddy
chemistry
needs an
stuff.
ad revenue paycheck. We're gonna. Okay, so.
Because I'm not super confident on it either. Like I kind of dropped this paragraph in my exam, I think, and that was it.
So here's the thing. Okay, I think I have a. Okay, I think like a decent enough. It's gonna work. Trust me. It's gonna work. So like, we have two cubes, right?
Yeah.
We got two cubes, and so if you have a ball, or a ball, sick. If you have a ball, this is gonna be actually. I just realized this is gonna be your line example, except worse. So if you have a ball in this box, it can't just go to the other box because there's a wall between them. So it can't.
Yeah.
But like if these two boxes were to like collide with each other a bit, just a bit, just like you know, just like a pinky toe dip into the other box, then the ball could still be technically in this box and move to this one. And then since it's in this, you know, this is not gonna work. But like, it's, okay, I get how it works.
Yeah, I get what you
how it
mean. I
works
get what
now.
you're saying.
It's
Yeah.
just this
You're
is
saying
annoying.
they kind of overlap.
I don't
mean,
like
it's
spin.
like this is a Venn diagram. You've made a Venn diagram,
Yeah.
right?
Yeah.
And you said that they both share a quality, but only a really small bit.
Oh, I don't like spin. I'm not gonna lie to you. I don't like spin. Everything I've came across in quantum mechanics and chemistry so far, I was able to make an analogy for which worked. For spin, I have nothing.
Do you remember what I showed you before about like the pictures of like spinning on its axis and that kind of stuff? 'Cause that is
I
the
remember-
best analogy we have because that's why we called it spin.
That's the best? No.
I mean, as in like it. Well, okay, the way it behaves is as if it were spinning on an axis. Except that axis, the like direction that axis can point, it can only point in specific quantized directions, and that's because it's quantum.
Yeah, but what really messes up the analogy, at least in my personal opinion, is I won't even explain exactly what I mean. I'm just gonna draw it for you. This is the bit that screws up the analogy for me, not gonna lie. You know how when you have more, right? The spin just that's the bit that really screws up the spin analogy for me. I know you get which part I mean. But, you know.
I don't get which part you mean.
It's like when you have a single electron to half, like when you add more, they start doing this. That's 2, and then you have 3 spin values, and then you have. This is from the diagram you've shown me, and then you
Okay,
have
yeah.
4. Do you remember the one?
Yeah.
I don't know what I'm doing. Okay, do you remember which one I mean? Because like I am.
Yeah, I do. I
Okay,
can get
yeah.
it up. Let me find
Yes,
it real quick.
this is the bit. If I could somehow link that bit to spin,
Oh, okay. I can explain it. Yeah. Let me get the.
then I don't think I'm golden, but at least I'm not a garbage truck on fire.
I'm gonna pull up 2 different lectures from completely different topics because they both explain this.
No confirmed. No, Ash, it's just highlighted to the person you're talking about. So for example, I can do this. There. Now this should be highlighted for you. Maybe my taskbar broke again. Ah, this is painful. The spin. The rest is pretty good.
Where is this? It's here.
Yeah, and that make it is highlighted on my screen. I can show you if you want. There. That's what I see. It's highlighted.
Okay. Screen share.
Alright, we just... Can I... Alright. I'll put on stream. There we go. Yes! That's the
Okay,
one.
this.
Yeah.
So I've got two diagrams up from completely different modules. But this is when you got loads of spins, and this is when you've got ones. Like, so this is like, this is one electron, right?
Mhm.
It can be either plus half or minus half.
Yep.
And when we, okay, let's look here. Let me zoom in a bit. So this is our electron, and we imagine it's spinning, and
Mhm.
as it spins along an axis, and we give that axis an arrow because it's a vector. And the reason we can say it points in one direction is because if it was spinning the opposite way, like anti-clockwise,
Then
then
it would be
the arrow
down.
would be pointing down. Yep. So what does it say here? Let's combine with circular momentum. Gives it angular momentum. That's why this has angular momentum. And this is spin angular momentum. So this isn't to do with L. This is our spin angular momentum, and this is the property we call S. So when I say spin, I'm saying spin angular momentum
Okay.
because it's spinning on this axis. Bold because it's a vector. Blah blah blah. This is about the charge. This doesn't really matter. This is just why it makes a magnetic field. And the actual magnitude of S is we multiply it by Planck's constant over 2 pi, and that gives us our like actual. This would be an actual like numerical value, but we kind of just
So
call this
the
half.
magnitude of S is the S, but the non-magnitude is the M of S. Right? Okay.
Oh, wait, I'm checking. Okay, no. Okay, so
Alright.
S is the magnitude, and MS is the vector, because MS you give it direction,
Okay.
which we talked about before.
Okay.
So S would be this, but without this arrow, because we're just saying like the maximum, like it's okay. If you think of MS, it can either be plus half or minus half MS, but that means that the magnitude is always half, and the magnitude is S. So S is half, and MS is plus or minus half.
Okay. 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 I get now. Slow.
And so here, yeah. So I think the like notation we've used here is that when it's in bold, it's like the actual numerical value, which would be this. Or he hasn't written it, but it would be like this with Planck's constant in that. But when we don't write it bold, it just means this normal half.
I've actually came
So-
across the notation of
Yeah.
writing vectors in bold, and I've got to say I hate it because it confused me for solid 2 hours.
I mean, this is
I
even
know.
more confusing because it's like this isn't the vector, this is the magnitude. So
Yeah, so it's
this
going the other
is
way.
even worse. Yeah.
Vested.
I think, yeah, for this, just ignore the bold thing. This is, I don't think this is relevant to this. This is for, this is my like EPR experiment. You know that presentation I gave you.
Yeah.
This is from this. This is like the lab book. So this isn't relevant. Spin has no equivalent classical property that helps you.
Of course. Be too easy.
Um,
Wait, can I actually
say
hold on?
Bohr magneton.
Can I actually
Yeah.
quote this in the video because? Oh wait, can I?
I think legally, it like belongs to my professor.
But can I
So
can I
I
say
don't think you can.
you know, from one of my sources, and then the quote. Because
Yeah.
wait, it's a single sentence. Oh, so
Yeah.
let them sue me over the single fucking sentence. Spin has no
Yeah, no one's gonna care.
equivalent classical property. Remember the Electron video where like I don't talk about spin at all?
Yep.
Yeah. I'm gonna include this instead of talking about
Okay.
spin.
I mean, I think it's relevant. It's really relevant, especially for magnetism.
I mean, it really is. It's just like if you're doing quantum chemistry, I think I should call it quantum chemistry. I just want to distinguish it from general. If you're doing quantum chemistry, it certainly is extremely useful. But damn, there's no explanation for it. Just accept it as a fact.
Sorry, I was drinking water. Okay, so this is what we have, right? We have our spin, and what this diagram here represents is it represents this diagram down here. So you need to remember when we say it's plus half or minus half, and he's conveniently written ms in here as well. So what he's shown is the magnitude is s, so that's like the magnitude of this. But when we give it direction, that makes it ms. And this, when we say plus or minus half, we're saying that's like the component in the z direction, in the z-axis, which means that we don't know where it is in terms of x and y. Does that make sense? So it's like
I mean, no.
this red arrow can be any of these red arrows. So it can be pointing anywhere along this circle, but we're only concerned with the z component of that arrow because we can't tell the x or the y component. So z is like the vertical, right?
Yeah. Okay.
And so it can be anywhere along this circle, but it doesn't make a difference. 'Cause
yeah. So I
these
feel like you're
circles will
explaining
cancel
it
out.
really well. I feel like it just doesn't make sense. Not
I mean,
your explanation
it's very,
only. No,
it's a
I
very
get the
difficult
concept.
thing. Yeah.
Yeah, I get what you're saying. It's just that
yeah.
the thing you're saying doesn't make sense. Not
Yeah.
yeah.
It's a very, very difficult thing to talk about because obviously I've spent years like on this stuff.
Thermodynamics.
So-
oh no, it's not. No, it's not thermodynamics actually. This is
So yeah,
just
you can see here he's even written here the magnitude is sz, so that's our sz equals ms. So our spin magnitude in the z component. So the z component. When I say component, like, do you know what that means in terms of vectors?
Yeah, you mean like one direction or just something?
Yeah, yeah.
Okay.
Like if you have a vector that points in like an x and a y axis, it has an x component and a y
Then
component.
yes, then yeah. Okay.
Yeah, okay. So that's what we're doing with this. It's literally just the z component of this vector. That's what we're worried about.
Mhm.
Because if you actually add up loads of these electrons, they can be in any of these positions here, and so they kind of just cancel out. And so the x and the y just cancel out.
Yeah. Okay. So basically, the average z is the only useful value, because average x and average y would just be always 0.
I think
Because
so.
no
yeah.
matter how far on the left you go, you also have the equal probability of going that far to the right. So
I think that's it. I'm not entirely sure if that cancel out thing is correct. That's just how I have it in my head.
yeah, like
But I know for a fact the z thing is like we
the
take
z
the
is
Z
the only
component.
one that's on average, not 0.
yeah.
Okay. So far,
Yeah.
you got me. All
Okay.
right.
Okay. And so it can, when we say plus or minus half, we're saying it's either pointing along our z-axis, or it's pointing the opposite way, like against our z-axis. I guess is how you'd say it.
Mhm.
And this is relevant when we have a field, which we've drawn here with B. Because the field goes like this, and so it's either aligning with the magnetic field, or it's going against it.
In this case, does either mean both at once, or
No.
Okay.
The electron will be spin plus half or spin minus half. and it's not like it's not both. It's not in a superposition. It's just it. If you pick an individual electron, it will either be spin plus half or spin minus half.
That actually, in classical mechanics, that would make perfect sense. But considering it's quantum mechanics, that bit actually confused me.
Well, it's like when we draw that when we draw those diagrams, you know, with the like lines, and we put the arrows on them for the orbitals.
Mhm.
That probably doesn't narrow it down, but like the lines with the arrows. When you draw those, let me just.
But the arrow pointing up is the aligned, and the arrow pointing down is the not aligned, right?
Yeah, I mean.
Good enough.
The align thing is only relevant in this context because this is EPR spectroscopy. Because normally when you have like an electron, you don't have a field on it. Like you're not putting in a field on it. So this B is only relevant for like this experiment where we literally have this massive magnet that we put the thing between, and the magnet just puts a field on it and it's massive. Like my professor made me hold, I think it was like a pen or something in the
Oh
middle.
yeah, I remember.
And
Yeah.
it pulled, and so it actually massive. And that's obviously not the context most electrons are in. So this B is only relevant for that. But we just say plus or minus half because it can be either pointing that way or that way.
Okay, so
basically.
in this case, it's just that electrons, when it comes to, so it's just something that they have. There are some electrons which are, so it's not like phase where electrons basically, where when you say electrons can be in phase or out of phase, you mean like they.
Electrons aren't ever in phase or out of phase. It's the wave function that's in or out of phase.
Yes. So when you say like that the wave function is in phase, can be in phase or out of phase, you usually mean both at once. So it's not like that.
Yeah.
For
It's not like that.
yeah. So for spin,
think,
it's actually they actually do have one.
Yeah, well, and the way to think about it is the whole point of me explaining this is I was talking about spin allowed and spin forbidden transitions, and the whole point is an electron isn't allowed to switch spins. And so then if you apply it to this, if you have an electron spin plus half, it's always going to be plus half because it's not allowed to go minus half.
There is one thing which confuses me about this, and okay, you know what? I'm just gonna draw it for you before you have the chance to explain yourself. If we have a hydrogen atom and a hydrogen atom, right? And they like bond. We don't care about the antibonding orbital because we're cool.
Mm-hmm.
And they bond. Then what if both electrons have an upspin?
I think you just this is gonna make you really upset, but one of them just changes spin.
Alright, cool. Yeah, that's
You
fine.
just-
That's fine.
Yeah. Yeah.
Wait, hold on. No, this actually can make sense. This actually can make sense.
There's this thing called pairing energy,
Okay.
where it's like putting two electrons together in an orbital requires energy. Like it's disfavorable. Like they'd rather be in two different orbitals. And for this diagram, I'm not sure if when we draw like two spin ups, if that's like just convention and it's actually always one up, one down. But I don't think it is.
No, that wouldn't make sense
so
for it
I'm
to
not
be
sure
one
on
down,
this.
one up, because then if you have
Yeah.
one up, one down, you can just bring in another who's one up.
Yeah, because the convention is to always draw the first electron spin up and always start from the left and work your way
Okay,
over.
so
right?
okay,
But
but
I
this can
don't-
actually make sense. I feel like this actually can make sense because there must be there either would be a way for them to switch spins, or they would keep their spin forever. And so it makes sense that
me just
there would
check
be
something.
some scenarios in which they would switch spin. It's just that they don't. So yeah, okay. So it is like really the colored ball example. Like a blue ball can't just become a red ball out of nowhere. You actually have to paint it red. In the same case, electron can't just switch their spin willy-nilly. They need a reason to switch their spin. Okay. By the way,
I'm
Nathan-
checking this because this is like actually a gap in my
Alright,
understanding.
I'm gonna give you a second. By the rush, by the way, I'm resurfing and responding. That is a Greek cool compliment for Ali, and oh boy, Z is vertical. I mean, yeah, I actually see that quite a lot convention-wise, because like you have the XY plane. XY is usually no plane.
Yeah, we always call it vertical. I don't know why.
Yeah, because
Chemistry is just that's our thing.
no, actually, it actually makes sense. The same thing as in Blender. Like convention is that that the Z is up. Y is up mostly when it's only 2 dimensions, because it goes basically. Oh, the last coordinate usually is considered up. The up is dumb anyway. Like you wouldn't distinguish front and right. Gravity, am I right? Yeah, we're in VR. Happy, where did you know? Wait, where did you know this lyrics from? Do you know from which song that is? Because I do. We're in VR. You can try to run, but you won't get far. My parents said, but don't say that. Stupendium song. Hell yeah. Find me someone cultured. But don't say that on post. Don't let the haters get to you. You're awesome. I always do say that. See, wow. FNAF Stupendium song. Hell yeah. Finally, someone cultured. Oh wait, I can actually string down. Okay, so spin. Vote for make it to sing I'm a bad girl. I'm awful when it goes to singing. I really am. I wish. Okay, so as a quick recap for everyone else, spin is analogous to electrons spinning, except it's not. And yeah, Babs was that doing ghost summary. So,
I think I was wrong when I was talking about the spin plus half can't change to spin minus half.
Oh, no.
I think that was wrong. I think you just give it some energy and it can flip.
oh, that actually makes sense.
And so I think I was getting mixed up with the stuff about forbidden states, because those are like states, not an individual electron in its plus or minus half. Those states are like the magnitude of S, which is like spin, or S half, or S 3/2, and those are states, and so it's spin forbidden. But to switch between
Okay, so
magnitude
in
from
this
positive
case,
to negative, I don't think it.
so in this case, the hydrogens don't care if they have the same spin, because if they do, the energy, the bonding energy, will just switch the spin of one
Yeah,
of them.
I think it's just the energy just does
That
it.
makes sense.
Yeah.
That really does make sense. I'm gonna skip the question of which atom will end up getting switched.
I don't
Because
think it makes any difference.
I mean, yeah, but it can only one of them can switch. Otherwise,
Yeah, I mean,
So,
this is a
I'm gonna
this is a thing in
skip-
chemistry. This pops up all the time in chemistry, where it's like, oh, it could be either one of these, and you just
Yeah, but-
choose to ignore it because it's just averaged out over billions of
but
molecules.
still,
So it just doesn't matter.
which one do they pick though? Okay, no. That's a
Well, that's the thing. This question can be applied to like everything in chemistry. Like, there's so many things happening at once that you can look at something and go, oh, why is it this one and not this one when they're the same? But it's like it just doesn't matter.
just yeah. I mean, I feel like that's something that's gonna be. I feel like that's one of these things which are gonna get researched in the future, and then they'll either discover a new force or a new particle that's, elementary particle just responds for like picking one thing over the other.
Just for picking randomness.
Yeah. The
The
RNG.
random particle. We found it.
Oh, but can you imagine, like, whenever the universe has to pick a random thing out of a pair, it just emits a particle, and because it emits a single particle, that particle only picks one.
I mean,
if I was programming
if you
it
come down
and
to it, it's probably just something to do with the energy. Like one just has more kinetic energy than the other, or something, and that just means that.
yeah, but then that
electron
leads
is
to more questions.
likely to
What if they
switch,
both have the same
Yeah.
kinetic energy?
Well, that's a big what if. 'Cause
Yeah,
it's
that
really
is a
difficult to
pretty
get.
big one. Listen, consider how many hydrogen atoms there are. It must have happened at least once, right?
Well, that's a whole other philosophical
Yeah,
debate.
that is.
That's that whole thing where it's like if there was a gas with infinite
basically-
time, then eventually it would form a brain.
It's basically
of the
the
second.
coin flip of landing sideways, where the two hydrogens just come together and they really, really want to bond. They're so close, but as it just so happens, their spin is the
Well,
same.
they're both the same, so the universe
Yeah.
can't decide. So it just they just don't bond.
they just crash the universe. Oh, that's it. Yeah, we'll have to make it happen one day in a large hadron collider.
Make it happen.
Have to
Yep.
make it happen. Bonk two identical hydrogens.
This is a
together.
diagram of this Z component, by the way. So it's like this is the vector, but what we're actually like concerned with is this red arrow here, which makes up the Z component of
Okay,
this
so
vector.
so the length of the arrow when it comes to the actual angled arrow, this is
Yeah.
always 1/2.
Length of which arrow? The
The
vertical
one on the right, the angled, the one at the angle.
Okay, I think the one on the right isn't half, but the one up is half.
Oh, I
and
see.
that's
Wait,
why
but
we call it half.
but the length of the angled arrow is constant, as in no matter
Yeah,
how
I
many
don't think
arrows
this
there are.
can change. I think it's always the same.
Yeah, so
length.
it's only the angle that changes. When you have, like, for example,
yeah.
three
it's
different
it's
states,
the angle. Yeah.
you have all of the arrows are the same. It's just the angle that changes, and that's what. Which means that the
Yeah.
height along the z-axis would just be some sort of trig function.
I'm just looking here to see where it. I'm trying to see because it should say this somewhere.
My brain is in a constant state of spinning buffer.
I think you're right though about like because here it's kind of hard to see, but the S isn't half here. The S is this magnitude, and then the MS represents our Z component of this magnitude.
Okay. So basically, the highest ms physically possible, theoretically physically possible, would be S. And the lowest.
No, so
MS.
you need to remember this the like angle that this is pointing at. It can only point at quantized angles. So it can't point. It
I
can't point
forgot it's
anywhere along
quantum.
here. So if I go to this,
forgot
it's like it
it's-
can only point at specific angles because quantum mechanics.
Yeah, but that's like what they mean. Because basically, if you add more electrons, you get more discrete values, right?
Yeah, I guess the higher
Yeah.
the
So
higher up
the
you would go, you would get
the highest
towards-
theoretical limits,
yeah.
if you have an infinite amount of electrons, would be for the ms would be S, and the lowest one would be negative S.
Yeah, that tracks with my understanding. Yeah.
Okay. I mean, the spin is painful.
Yeah.
Because how, like, in classical mechanics especially, whenever you don't understand something, you can always be like, oh, don't worry about the math. This is basically what's happening. So for example, oh yeah, you don't have to worry about math too much. It's just that, Boltzmann.
Yep, love Boltzmann. But Boltzmann's great because all his stuff is to do with how, as you add heat, the population of these states changes. So it's like if you imagine in these, this is just an example from like my exam on Friday, but if this was like 0 degrees Kelvin, then all the electrons would be down in this lowest state.
Oh,
But as you apply heat, more and more of them can populate these higher states.
wait, wait. Hold
I
on.
think this
Oh,
is in a magnetic field though.
Wait, is that why superconductors have to be cooled down really, really low to
I don't
allowing
know.
the spins?
I don't know. I can't answer that.
Okay, so but that's hold on. I have to check it now because that seems like that actually seems related. Please let it be spin. That would be a lovely full circle. Spin. Spinning superconductor generates a London moment. Oh yeah.
London moment.
I love it when things are called moments in, you know, dipole moment, stuff like this. This is a certified dipole moment.
Actual dipole moment.
And then with the spin axis, then another moment was with a good use. No, it doesn't matter spin. No. Damn it, I really thought I got for a second.
I'll see if I can find it first, because I know where to look.
I know, we're just both typing ASMR. I keep getting ads for old white men in suits trying to sell me suits. Buy some at least. Maybe a good suit, you don't know. Why does it have to be cold?
Oh, I think superconductors are like really complicated with this stuff.
Oh no.
Like it's way worse than this.
Wait, hold on. They only become superconducting at extremely low temperatures. The search to find theoretical computational methods to represent and understand this fact has been going on for many years. As yet, no one has fully succeeded in finding the solution. So this is basically, oh yeah, it works. Don't question it. We don't know why. It just does. Yeah, so basically if you cool it down to extremely low temperatures, you basically remove the resistance. Why? That's a silly question. We have no idea. How did you even find out about this whole thing? Like, people question.
Well, this is what we do in materials science.
You cool
test
down
limits.
random materials to, I don't know, 100 Kelvin. Well, actually, I think it's...
100 Kelvin is pretty high for this.
Yeah, I think like it was around
the
80
theory.
or 70 Kelvin. People question how did humans figure out that you can milk cows. we have no idea why superconductors are a thing.
That's a lot of stuff. Is like we discover it and then we explain it later,
How do you discover something like this?
or just chance and.
Hey guys, I have
trying
an
out
idea.
stuff. I mean, they could have easily been trying out something else with like conductivity, and then they just.
Hey guys, I have an
stumbled
idea.
over
Let's
it.
take this material, let's cool it down really low, and let's try to measure its resistance. How high are the scientists in these universities? They,
I'll let you know in a couple weeks when I'm doing research.
like, there is no way. No, they need a whole department just dedicated to growing weed in order to come up with something like this. Okay, to be fair, that was in 2019. Maybe there's been a new development in the past 5 years. Someone explained conductivity. Okay, there we go. Conduct without energy loss. Also expel magnetic fields as they transit. Okay, so it could be possible it's due to spin. We don't know.
I mean,
That's an awful answer.
the magnetic part is definitely related to spin. Yeah.
These materials also expel magnetic fields as they transition to superconducting state. That's why it... Because that seems related.
But you've seen those things about like the magnetic locking, where it's like, you know, if you have a superconductor and you put it above a magnet, it's like locked in that magnetic
Yeah,
field.
and you can move it around
won't
and it
move.
stays. Yeah.
Yeah.
That's also bizarre. You mean to tell me we basically like have Wingardium Leviosa as a metal, and we just don't know why? Cool. No, that's fine. That's fun. Yeah. I'm actually questioning what is spin.
Oh, I found a molecular orbital diagram.
Oh, okay. So, okay, hold on. I'm almost there. I'm almost there with spin. I'm like, it practically clicked. I am so close.
Mm-hmm.
So spin. There's no good analogy for spin. It just exists.
Not really, no. We just kind of imagine it's spinning on an axis, and that axis can only point in specific directions because it's quantum, and
And
by
these
spinning,
specific
it makes
directions
a magnetic
are
field.
determined by the number of electrons. More electrons, more discrete. Oh no. Whenever I hear say, that's never a good sign. Oh no.
Wait. Well, you mean these? You mean these?
Yes.
I'm trying to think. I think these are. Yeah, I think you're adding spins to get these bigger vectors, because that's what we did. It's not even here yet. It's lower down. It's somewhere. Where is it? Is it in a different slide? I showed you at one point where we were just adding these arrows onto each other. I
Okay,
think that's
Okay, hold
this,
on,
but
but
then wouldn't
also-
these arrows be different lengths? So
Another
that's
thing.
confusing me actually.
Another thing. When we have multiple electrons in what? Is that in an orbital?
This is in like a system. So in this example, this is the only context I've like learned this in. But this is all metal, metal atoms basically.
Oh,
So in this context, you would have like iron 3. Let me draw it real quick on slipping tool.
By the way, Lampos to me saying that had someone discovered milk. Lampos just replied, "Oh yeah, animal sucking wasn't illegal back then." Paints a picture. Hi Denayam. Hi, welcome.
Okay, can you see?
Yes.
So iron is in this iron 3 state. So I'm drawing our d orbitals. So we have 5 d orbitals, and in iron 3, iron is okay. Iron 3, it has, we say it's just got 5 electrons. So is this blue a bad color against the background? Let me switch. So these are 5 electrons, and we draw them like this instead of like paired up, because that's convention. Because
Okay,
they
okay.
want to be in different orbitals, right? They would rather be in different orbitals unpaired than be in the same orbital paired
Do they
together.
want to have the same directional spin, or is that convention?
I don't think it matters. I mean, in this convention, I think, yeah. It's a different question. It's a difficult question. Let's ignore that for now.
Okay.
But you can see each of these is half, and so on this whole atom, the spin of the atom, the electron spin, the total S, which is capital S because it's more than one electron, is 5/2, because it's 5 halves, so 5/2. Because you just add them up. And so then if we go back to going back to this, that's kind of what we're representing here, where he said the magnitude is okay, so he said the magnitude changes as well, so I think the magnitudes add up, and something, I'm not really sure how you get from like the individual one to these, but we're saying if this kind of atom can exist because its overall spin magnitude in the z component is 5/2, then the SM values are plus 5/2, plus 3/2, plus 1/2, so on.
Okay.
So it's like our magnitude is this, right? And we're saying the maximum we can have is 5/2 in this state, but well, it's this, I guess, but yeah, up to this circle, it's 5/2 in this state, but if you make this SM instead of S, then we have these values, because that puts a direction on it. So I think, oh sorry, NS, not SM. ms. And so that's what he said here. The magnitude of the z component in each orientation.
All right. This is awful. I hate this.
Yeah.
So. So here's the thing. I'm gonna ignore spin.
Yeah,
In all
that's
my
fair
videos.
I think that is fair enough.
I feel like I'm gonna script a chapter for the election video. At the very end, I'll have a short chapter, which will be, oh yeah, I forgot about spin, basically chapter, and that entire thing will just be explaining. I won't try to simplify it. I'll just explain in the most confusing way possible, because this is just math. Like there has to be some sort of physical reason behind it. We just
I mean, I think
don't
it
know
kind of,
what that reason is.
yeah, like what's being taught to me makes sense, but I know it comes from maths, so
Yeah. So okay.
Yeah.
So yeah. So basically, there is some sort of physical
and
reason
I've
behind
also
it.
spent years like understanding this,
I don't.
and even
Is there
you can tell
anything
even
to
I like
understand
don't
that? I feel
understand
like-
it great. It's-
I don't know if there's anything to understand. Oh. Oh no! 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 Oh no! 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 No!
Oh, this is the thing we said before about them summing to 0. So yeah, in the XY direction. So yeah, when you have loads of spins, the X and Y just cancel out.
I'm done with spin. No.
Yeah, that's fair. That's fair.
Oh, all of this was
What,
basically.
do you want to go onto like?
Hold on, because all of this was
photons?
just so that I can understand phosphorescence. I don't know if you remember. That's
Yeah, because you
That's-
you were like, oh, explain the S and the T.
yeah. That's why we were doing all. I remember now. Yeah, just a quick explanation of spin. Actually, that was phosphorescence. Okay. No, I get it now. I don't, but I get it. Listen. So here's the thing. Okay. Phosphorescence. It can transition from S to T because spins can just change. However,
Yeah, you can't just change the spin state.
yes. However, it does transition from S to T because of the hole, and the hole in that case would be, I still don't get what the hole is actually.
It's like, okay, we'll talk of it in terms of colors, right? So say you have something that's pure red and something that's pure blue. So you got a red ball and a blue ball, and you're like, okay, this ball can't switch between red and blue. Like you can't go from this, you can't jump from this ball to the other ball because you'd be switching colors, right? But then if you actually look at it, and you look at its RGB values, and you look at the red ball, you look really closely at the RGB values, you can actually see it's like 255 red, but it's got like 2 blue, you know, an RGB value of 2 for blue. And so it's got a tiny bit of blue in it, which means you're actually allowed to just switch from the red to the blue. To the blue
Is
ball.
it basically
Is that like,
electrons just going off on a technicality, basically?
yeah, it's like
So-
because they're slightly the same character. We call it character when we're like mixing orbitals and states. It's like this, their character isn't purely different spins, and so because they're not
So-
purely different, they
This
can
is
switch slightly.
So dumb, by the way. Can we just for a second appreciate how dumb it is that like electrons can only have discrete values? Like that's the big thing,
Yeah.
you know? No. They have to have discrete values. You know, that's the big rule. But there is no problem with them having multiple discrete values all at once. Like, you know, your position has to be a discrete value. That's fair. But you can be in multiple places at once. There is no problem with that. That's an analogy. But that's... So basically, they can have, like... They can only have discrete spin values. I already forgot what the exact name for it was. But they can have a lot of one spin and a little bit of another one.
Yeah,
Okay, I get it now.
yeah. It's like the orbital is made up of like a mixing of some other orbitals, which means that the spin state is not purely what it should be, because there's some other orbitals involved which are mixing in. I think it's the angular momentum gets involved, something like that, and it just mixes it.
Okay, I already have a perfect analogy. I'm gonna basically do. You have a red ball, you have a blue ball, and you can't switch from the red ball to the blue ball because you'd be switching colors. But now imagine that the red ball hits the blue ball, and it stains it. Now because of this stain, you can actually be purple, which is kind of blue, and switch to red. And then at the end I'm gonna say, yes, this analogy does not make sense, neither does anything when it comes to spin, so just squint really hard, pretend it's correct, and do math.
I don't, the ball analogy is difficult because it's like that's not how color works.
It's
but
not the
in
ball
terms
analogy
of the
that's difficult,
RGB
it's
values,
the electrons
it
that
works.
don't make any sense!
Yeah. Let me read this again. Okay, coupling exists, which arises from magnetic interactions between the orbital motion of the electrons and their spin. Spin orbit coupling. Okay, it's not mixing with other orbitals. It's this L component like messes up our spin, basically.
Don't
Why is
try.
the L getting
Don't.
involved in the
There's
spin? This doesn't even talk about how the L how the L gets involved in the spin. It's just like, yeah, the L just messes it up. Okay, this coupling adds perturbation to the Hamiltonian of the system.
in this case
I
it
don't even
is
know what
just
this is.
this Z, I think.
Probably.
They just run out of letters over there, honestly.
Yeah, we've used like every Greek character at this point.
Why do everyone need an analogy to understand something? Nam, go right ahead. Try it. Do anything with spin. I would go right ahead. Go right ahead. Or explain spin without an
spin
analogy.
is just difficult.
It's not difficult, it just doesn't make sense. Like,
I mean,
in
that's
this
why
case-
it's difficult. I mean, it's difficult to understand. Like,
in this case,
to
I
understand
get
it fully, like, form a picture.
Yeah, I get that this works and that's fine, but that still doesn't make sense. Understand it by itself. Nahem, go right ahead, try it. I would love it to have someone who gets spin and just take over that segment of the video. I will animate anything for you, alright? Just talk, I will make all of the animations, take over the segment, if you understand spin. Go right ahead, be my guest. But yeah, so spin is basically just like, it comes from math, completely unrelated to physics, but it works.
I mean, it kind of comes more from measurements than from maths, actually. It
No,
depends the way.
that's what I mean. But because like in physics, you have a theory for why something works. So like
Yeah.
in physics, if you increase distance, that means the velocity must be higher. I might understand spin, but I will need an analogy to explain it. You told me that you can understand it by itself. Spin is awful, absolutely awful, because it has no. Not even that it has no classical mechanics analogy. Actually, analogy isn't even the right word. It has no, like, physical. I don't know what to call it. Spin just is.
Like a physical, like a classical comparison.
I don't think you even need to say classical. Even in quantum, what is spin? Well, it's kind of like
I think in
electron
quantum
spinning.
it does work. It does work with stuff.
The math works. Not
the maths
thing
works
itself.
as if it's just.
Do you know?
As
Are
if
you
it's
familiar
just
with?
spinning and it's got angular momentum.
Are you familiar with tetration?
Titration or
No,
tetration?
tetration, as in mathematical operation. Tetration. Yeah, you might
If you
not be.
describe it, maybe it will ring a bell.
You probably aren't, because most people aren't. So you have addition, x plus x, right? And
Yep.
that's addition. Then you have multiplication. So, well, actually, you know, let's do right here, x plus 2. Then you have multiplication, x times 2. Then you have powers, x the second power, and then you have tetration, x tetrated 2. and basically.
Oh, I have seen this.
Yeah.
I think I watched
Yes.
like one YouTube video.
And so basically, the basic idea is, x plus 2, that's just x incremented twice. X times 2, that's just x plus x. X squared, that's x times x, and then x tetrated, that's just x to the power of x. But you know what's interesting? When it comes to tetration, there is no standard notation, there is no standard definition, there is no standard like rules for it. And the reason why is because even though tetration makes sense in this way as a mathematical thing, there isn't a single place where you can use it. In physics, chemistry,
Yeah, because everything
anything.
just gets too big as well.
It's not even the fact that it gets too big, it's the fact that it's not useful for anything. There isn't a single thing you can describe with it. And because of that, and because of that, we actually have a lot of trouble understanding properties of tetration. That's the reason, because, we get the mathematical idea behind it.
Oh, things like if you had like a half value there instead of 2.
Yeah, that's a perfect example. So, what tetrated
Like we
one
can
half.
understand that for squared, but for tetration, it's like you have to wrap
Precisely.
your head around it and spend some
And
time with it.
that's what I feel like spin is. So mathematically, it makes perfect sense, and if we apply it to the electron, we get accurate results. But like, in real world, saying that electrons have spin, that's a bit of a stretch. Like, yeah, they can be described well with spin, but saying that they have spin would suggest that it's like a real thing.
Yeah.
Mathematically, it is, certainly. It is. Why is physically? Calling in spin is also a war crime. Oh, wow, okay.
Calling
Okay.
a spin was it's really funny. It's like, oh yeah, it behaves like it's spinning, so let's just call it spin.
It behaves like spin. I mean, it doesn't. Absolutely doesn't in no way, shape, or form, but it kind of behaves like it's spinning. Yeah, they spin, but they don't. So they don't spin, but they spin, so it's spin without spin. So yeah, you have like, angular momentum. Like spin angular momentum. Well, imagine if it wasn't spinning, if it, and if it didn't have spin angular momentum, but if we still used it, and so then imagine it has like a lot of them at once, but only one, and like it can only be discrete except when you add more, then it's different discrete values, which I guess wouldn't be discrete, but it's different, and like they have a certain value which cannot change. I mean, unless it does change, but then it changes and it's still the same. And like if two things come together, we just assume they have the same spin, and then they don't, even though we don't know what spin they have. It's easy, it's simple. Why would anyone be confused? Oh, pentation, yeah, because then after tetration there's a pentation, and also I think hexation keeps going.
As soon as you wrote it with the 2 in the top left, I was like, oh yeah, I've seen a YouTube video on this. But
Yeah.
it was like a year ago, and it was one video, and I'd never seen it anywhere else.
Yeah, because it's just, I mean, I can even, I feel like there were some things on that. I think tetration to the negative first. There was a theory about it. Why did I Google Wikipedia? That's about it. The point is, tetration. Yeah, like right here. Not to be confused with titration. Tetration hyper 4 is an operation iterated exponentiation. Yeah, we don't even have standard notation for it. Like
Yeah.
sometimes 2 arrows, sometimes 2 behind it. I actually did a whole mathematical theory over a year ago, jeez, called hyperoperational mathematics, where I started. Yeah, tetration also, the gram doesn't, it's all bizarre.
Oh.
And you have this whole Wikipedia article, which is really funny because you have all of this information and none of it's useful. You can't use all of it, and it's not useful in the purest way possible, because even the mathematicians, we sort of create math. So in this case, we don't even have a standard for it.
Yeah.
So I do
I do
believe, like,
sometimes look at this maths, like certain maths discoveries, and I'm like, damn, it would be really cool if we could like apply this to chemistry.
I feel like
But
most
do you,
of it.
you know that did you ever see the I think it was it a Nobel Prize last year in maths where it was like I don't know if it was a Nobel Prize or just a guy discovered it, but it was the regularly repeating shapes. Oh, what was the name? Wait. Let me try and find this.
The repeating shapes? Fractals?
Wait, I'm trying to find it.
Oh, by the way, Ali, thank you for the compliment about the pirate make it. Also, I don't know if you can see, but is the parrot that's actually talking, not me? You can there. Make it is the more.
It was a tile. A new geometric shape was designed that's a tile that creates a tiling pattern without repeating, and it was the first monotile that they found. So like single tile that could do that, like ever. Like it had been known way before with like more than one tile with stuff like I think Penrose tiling and that kind of stuff, but they discovered this like
Wait, a
first
singular?
repeating monotile.
Oh, that's really interesting.
And I was like looking at that and I'm like, damn, wouldn't it be really cool if you could like apply this to chemistry and
like-
make like a crystal structure that used this?
I feel like you could. It would just. I feel like that would be doable. I mean, for most things
Yeah, I
which
mean,
are
well, that's the thing because
discovered-
this is in 2D and chemistry isn't in 2D, so it's like
First
it
of all,
doesn't really.
graphite begs to differ because even though it's
Well,
it's 3D, you can still explain it pretty well.
Yeah.
But second of all, for all of these math inventions or discoveries, I don't know what to call it, they always find a way to get involved in different areas. And chemistry is, I would say, well, no, physics is the math's favorite, but chemistry is the math's favorite when it comes to things that make sense. Spin is quantum mechanics; it can suck it, but for everything else, everything in chemistry makes sense. That's why I like.
What do you
chemistry.
mean in terms of maths in chemistry?
So hold on, as an example. Give me a second. I'm trying to think of something creative for this. So, for example, no, that's not a good one. I'm having trouble drawing a line between quantum mechanics and chemistry right now because, like, phase, for example. But that's a silly one because that's waves in general. I know it's a bit more quantum mechanics than chemistry. Well, no, hold on. I can do it. Give me a second. I can figure this out. I can think of a good one. Bands. Final answer. So, for bands, you basically have a switch between discrete values and continuous.
Yeah.
Which, well, technically isn't a switch. It's more like a very gentle flow from discrete to something that's not at all continuous, but if you squint really hard, it is.
Yeah. Well, it's like you have so many molecules that it just averages out.
I just realized.
Or not molecule. I mean, in this context,
I
it's
just realized why
lattice, but
physics
yeah.
is like why physics prefers physics is math's favorite and not chemistry. Like in chemistry, you have, I don't know, sextillions of molecules, and you're like, oh yeah, that's practically infinite amount.
Yeah.
and in physics, you have like, oh yeah, we have absolutely no idea what this property is, but we're gonna assign it a number, and it works. We don't know what it is. We don't know what causes it to happen. We don't even know if it's real or if math just happens to make sense. But we're gonna call it spin.
I mean, I assume it came like. I think they do know it's like it's literally like an angular momentum. It's just
No, it's not.
The confusing bit.
It's
the confusing
similar.
bit is that it's not actually spinning, but it is an angular momentum property.
Yeah, it's not angular momentum. It behaves like angular momentum. I get that. Honestly, if it quacks like a duck, if it floats like a duck, it's a duck. That's a fair argument. The problem is, for me, is
No,
that
I
it
think
doesn't really
spin
behave
literally
like that.
is angular momentum, but it's just angular momentum without actually spinning. It's just like angular momentum that's come from nowhere, basically. It just doesn't make sense.
No, but that's my problem, because like, I get the argument if it quacks like a duck, if it floats like a duck, it's a duck, right? If it behaves like if it behaves like angular momentum, then it's angular momentum. Even though it's not spinning, it behaves like angular momentum, so it's angular momentum.
Yeah.
I get
So,
the argument.
yeah.
My problem is, does it really behave like angular momentum?
I think it literally is classified as a type of angular momentum.
In quantum mechanics, the
I think
discrete
even in like
values-
physics, it's just yeah.
hold on, electron spin. It feels.
Because I think the point is it is angular momentum, and that's why we call it spin. Because we're like, oh, it's got angular momentum, so it's basically as if it was spinning.
Make it, don't think of it physically, think of it mathematically. I mean, mathematically I get it, it's just that, look at the formal definition! Oh, fuck. Like, this is thinking of
Yeah.
it mathematically. This, oh, wow. I mean, yeah, it's angular momentum, right? That's practically what it is. You know all of your favorite angular momentum equations in classical mechanics. where you run out of Greek alphabet. Oh, mathematicians, bingo. Oh, sigma, rho, nu, I think it's a lambda. Wow.
If you rearrange that equation, you get the whole Greek dictionary.
Yeah, I can write my. Oh, epsilon's also there. Wow. Oh, I can write my channel name. Oh no, they're not actually. Oh no, wait, that's only Greek alphabet. There's no alpha. Oh, it doesn't depend on the angle. Well, that's convenient. Formal definition. Oh, yeah. So, like, physically it doesn't make sense. Mathematically, you're about as far away as from it making sense as possible with it still working. Cool. When I started this live stream, how can you think of angular momentum talking about spin? But it's not spinning. That's my problem.
Yeah, the point is it's not spinning.
I mean, hold on. Electromagnetic moment, that's a phenomenal name. I like that
yeah,
name.
I think that's the other name for spin, right?
That's a much better name. Because it really is electromagnetic moment. So it's like angular. Yeah, so it's like.
Well, magnetic moment is different to spin, isn't it?
I don't think so. It's the same Wikipedia article, so we know. That's my that's my source.
Okay, yeah, electron spin redirects it. Okay, yeah, yeah.
Electron. Wait, magnetic moment. Magnetic moment. Let's consult Britannica. Who the heck named it spin? That, yeah. Honestly, I mean, a while back we did a stream where you basically put it perfectly, where most conventions in chemistry exist because people just think there is a reason behind them. There never is. Well, there is a reason. There's never a good one.
Well, it's about the conventions kind of just come about not even because they're looking for a reason, but just because it's like
Might as well.
they can't be bothered to give something a good name, so they just stick with whatever name
Or-
someone first came up with.
Or number.
Yeah.
I'm not going to. No, I've
I know.
I've already done it too many times to flame. Magnetic moment. Well, brilliant. Wait, where's Britannica? Britannica. I need a good source. There we go. Magnetic moment.
Oh my god, I'm tired.
No, why would you be tired? We're having so much fun, aren't we? Just, magnetic spin.
I woke up at 7 today to study just before my exam.
I'm glad you can rest now, studying about how
Yeah, I'm
spin
just gonna
works.
stay up playing Valorant all night, I think.
Oh, you're a Valorant player. That's close to
Yeah.
the finals. You surely don't have that space.
No, that's the thing. My
I'm
PC,
smooth.
like, my PC is great, except it just doesn't have much space, and the issue is I also have Genshin Impact installed, and
can-
that
I can
takes up
give you-
half my hard drive. It's half the drive, and so I just don't have space for anything.
I can give you one recommendation which I've been using, which is this, which is like a visualizer, which just
Oh,
visualize.
I already have one. I already have a thing that visualizes. I use Space Sniffer.
I
It's,
think
like it's the same thing. It does the same thing. It's that picture.
I remember one
yeah,
of
it
those was
literally shows
literally like windier stuff, windier start, except it was multi-threaded. So if you use Space Sniffer, that might be just objectively better. If that's the one I'm thinking about, but
Yeah.
yeah, even with this, oh wow, call me president. I have on my drive terabyte, no, 1500 gigabytes of just things for videos. 1500, which is fair bit.
No, my thing just doesn't have any space. I think it's like 128 gigs total, and Genshin takes up like 80, and Valorant takes up like 40. It's just like it just it just scales up really quick.
Lampos say moles are a great unit. Make it will notice your message and like it. I mean, moles can't really be great units since they're not a unit. Doesn't matter. It's fine. I'm 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 fine. Okay, I get it now. Well, I don't, but you know.
Yeah, this is what happens when you ask about spin. Learn your lesson.
No, yeah. I won't question spin ever again. I want to rest. I've too much for me. I'm playing the finals. on stream
we
right now.
have like exercised your brain to the limit, I think, today.
Well, it's not really that. I mean, I could learn some more. It's just that I'm not really tired. I'm just sad because of spin. Spin isn't really making me tired.
It's just made you depressed.
Yeah. You know how like the best moment when it comes to learning is when it clicks.
Yeah, no, it doesn't do that
For
with
spin, it feels like it's like it's like a permanent moment of edging where you're always where you're always just right there. It almost click. It almost makes sense.
I unplugged my headset on accident. I was laughing too hard.
I'm like Shakespeare, honestly. Sometimes I'm thoroughly lost, but having a good time. Well, Ali, if I could cheer you up, I don't think even Flame understands anything more about.
I understand it better than anyone here, and even I like.
I feel like we
It's-
should
it's my
draw a
limit,
line
really.
between knowing and understanding. Like you know a lot about spin,
Yeah.
crazy lot.
I mean, yeah, I've had to use it loads.
Yeah.
And I, yeah. I've
The
done
understanding
loads of
is a
stuff
bit
with
that is
Yeah,
non-existent.
it's like I know a lot of theory with spin, and I know these diagrams and stuff, but it's like that's as far as it's gone. Because there's a certain point with understanding spin, I think, where it's just like it's just physics, and it's really difficult
The
physics.
fact that it
and,
doesn't
I don't
exist,
care.
mainly. That's like my biggest issue. Like it does exist,
ju-
it just doesn't.
Yeah, the angular momentum is a property that the electron has. Like that's a fact. Like it has that property, but I think we don't know where it comes from. Like because it's not spinning, so it's like how did it get there?
Wait a second, you're not spinning. What do you mean? That's not right. That's what I'm having trouble wrapping my head. Because, for example, this on the surface isn't as confusing. Like, charge is very similar, right? Electrons have
Yes,
charge.
like when you look too close at it, it opens up a whole can of worms.
But that's my problem with it. Because, like, for charge, it is very similar. Electrons just have charge. Why? And this isn't confusing, actually.
Yeah.
The fact that you can't answer why, they just do. That's what they are. They practically are negative charge. So it makes sense for there to not be an answer, right? Because they are. That's what makes them elementary particles. They have charge, no explanation, because they are elementary. That makes sense. I'm not confused by that. My problem with spin is that if you're saying that they have that, and I'm not supposed to question it, that's fine. But then you're also saying that they're spinning because of that. Because unless they're not, in which case, in what universe does it relate to spin? I know it's awful. It's awful. It's bloody awful. I'm
Bloody awful.
this. No, depressed.
I'm gonna order a pizza.
I was doing physics in the background. But
I need to treat myself after my exams.
Oh yeah, do.
I was studying so hard, you don't even understand. Like,
No, I
spending
believe you.
hours and hours.
I mean, I can tell from how much you know. You do know a lot.
Well, I mean, lots of the stuff I've talked to you about isn't stuff I've like spent hours and hours studying. It's just more like we've gone over it
it's
so
more
many
like
times that it's-
I don't want to say aura, but there's like a certain way where if you know a lot about something, you feel more comfortable talking about it, and then you basically you just know. You just know stuff. So for example, I'm trying to think of a good one. For example, like if I ask you about how, never mind, don't listen to me. I was trying to come up with
You're
an
about to
example.
say
I'm done.
Fourier transform?
No. I was gonna say fluorescence.
Oh yeah, I mean, yeah, I know that well.
Yes, that
I
would
mean,
be
I
a good
guess yeah,
example.
I did study it because it was like literally in an exam. So I did spend time, but like I understood it like the first time it was brought
Someone-
up, like in the lecture.
If there was like a task to explain fluorescence, I mean no, if there was a task to explain fluorescence, that would be fine. That if there was the task to explain phosphorescence, I would just draw a big middle finger on the paper. Like
That's the thing, because
I don't
those are the kinds of questions we would have got. It would be like, literally be like explain the, I don't know, explain the different states the electron, not the electron, the molecule transitions to during phosphorescence or something. Well, it will ask us a question, and then you have to apply your understanding to the question.
which is a very good way to check it. That's precisely what I need for most of these videos. So that's convenient you're here.
Well, you just want questions. I mean, I can give you. Let me see. Actually, maybe
Listen, I'm not
this-
getting answers. Might as well get
this.
questions, okay? If I'm not getting answers, might as well go for the questions.
Let me see. Maybe this has something. In terms of spin, it was never like examined in terms of like just spin, because the two main contexts I've learned about it are in this EPR lab where we just talked about some theory to go into more detail, and in this exam I just had where it's like it's applying spin in different contexts. So they're not. Nothing like asked about spin. Let me look at some like first year stuff. I feel like first year just didn't even mention spin. It was just like, it's just like yeah, it spins. Except it doesn't.
No, it doesn't. Oh, so chemistry. You know what? Chemistry is a huge. It's a mix. I have a love-hate relationship with chemistry, honestly. Because on one hand, it makes sense, like molecular orbital theory. That's phenomenal. I love that. Drawing the graphics, everything down to the graphics, from the understanding, the accuracy is
Yeah.
honestly amazing. And then you turn around and you're like, oh yeah, those electrons also have spin, but they don't. I love a love-hate relationship, honestly. It really is. But I wanna make you sound or something, but I don't have anyone to tell, so sorry. Wait, what happened? Come on, wait. Try again. Ah, lamppost. I'm not gonna get mad, just... Please don't again. Please don't. Please tell me it's the last time.
They're definitely a fish out of water.
It's not that you're making me mad, you're just making... I just don't want you to die. It's so weird that way. Okay? It feels awful because I'm saying it, we're playing finals in the background, but like... Just don't. I'm not gonna get upset over you because I know you have reasons. And I know it's tough.
I think I've
Spin,
found the only lecture on spin in first year, and there's one slide that talks about spin, and it's It says an electron possesses spin. It can be imagined as spinning on its axis,
No, it can't.
clockwise or anti-clockwise. And then these are labeled with the MS number. And no more than 2 electrons may occupy a single orbital, and if they do, their spins must be paired. And that's it. That's literally all it says.
Honestly,
And it has this diagram which isn't even accurate to like the more advanced stuff. So
honestly, I'm just in love with the quote that like there is no analogy for spin.
yeah.
Wait, hold on. That's actually something that gets me confused because when it comes to magnetism, isn't magnetism caused by spin or charge?
Both. Because if you have a charge that's spinning, then it creates a magnetic field.
Oh, I see. So it's basically like charge is the driving force of magnetism, but spin is okay. How do I? So, okay,
I
and
don't
this
know
is gonna
which
be a
comes
stretch
first.
of
I
an
think they just
analogy.
add together to make magnetism.
Okay, this is gonna be a stretch of an analogy, but like we're talking about spin, so just at this point, you just have to get used to it. But if you have momentum, right?
Yeah.
Charge would be like the momentum, the mass, and a spin would be like the directions vector of velocity. Stretch of an analogy, it's spin. There isn't much I can do about that.
I mean, the way I just think of it is like if you, in classical physics, when you have like a wire with charge flowing through it, that makes a magnetic field because the charge is moving. And if you had that wire in a circle, then it would make a magnetic field pointing in one direction.
Yeah, I mean that makes sense. I just don't know how spin relates to that.
Yeah.
Because
The spin is just like you're giving it angular momentum, and so it just makes a magnetic field because you have a charge.
Because it really seems like you can just explain it just well with just charge, unless I'm crazy.
Yeah. What do you mean? Explain what just well with charge?
Well, if you have a lot of negative charge, you're gonna create a magnetic field because, well, that's how charge moves. Like voltage, basically, is a difference in potential. So
I don't think the magnetism comes from like loads of charge in one place. Like a magnetic field is like a different thing to charge.
okay, so charge without spin, electricity, charge with spin, magnetism.
Charge without spin isn't even electricity. Electricity uses charge, but for me, like I deal with charge every day, and it's like it's not in the context of electricity. It's just charge moving around different molecules. And then
WTF, I thought we were all nerds. We're literally talking about electron spin right now.
Defensive strategy. Isaac Newton would not be happy with this. Everything from
In order for us to imagining spin. There is no way to imagine spin. There is no way to imagine spin. You can't. I feel like this is a provable fact that you can't imagine spin.
I mean that what they teach us is you can imagine it like it's spinning for like most applications. It's just that when you actually really want to look at it, it's not spinning.
If you squint,
It's
it's
essentially
spinning.
like it's an assumption you make for the sake of simplicity, because in most contexts, that's all you need.
Electron
And that's
behaves
what we
like
have
it's
everywhere in
spinning, but
chemistry.
it's not spinning. That's actually, yeah, I feel like it's actually just
30 seconds left, June. God, I'm on the edge of my seat here.
that's the only place you can go with. I really wish I could understand magnetism because the spin of magnetism doesn't click for me. And here I don't mean how it works exactly, I mean like how it relates. It would make kind of sense for the positive magnitude spin to cause, positive magnetic field charge, I have no clue, and then negative magnetic spin, the opposite to the z-axis to cause negative one. That would make sense, but there's no way it's that simple. It's never that simple. Just the packer.
I'm trying to order my pizza.
Nah, that's fair. What kind are you ordering?
I usually get like really spicy. I'm out of spice.
Oh yes, that's a good choice.
Just gotta make sure I don't order to my house in London.
You can just drive quickly, pick it up.
10 seconds left.
No, it's 2.5 hours away.
Yeah, you have to just drive really quickly.
I'm gonna change my location in the app.
Now again, I honestly feel like I'm in my negative these days. I try to, sorry. I feel like
The Kingfish have also qualified after an impressive
don't worry.
performance.
Okay, so whilst it's not fun getting share of negativity, I'd rather you do that than not share, honestly. I feel like I'm gonna do it now. I don't like. Lamppost. Could I convince? Is there anything I can do? Anything.
Is this an addiction?
No. No. I'm sorry, Flameful. Like, wants to bring you into this. It's just
Oh no, it's fine. I'm ordering pizza. Don't worry.
that's fair. That's fair. Numbers. If I'm gonna be a venting person, I am completely fine with that. It's just that if there's anything I can do, just tell me. On a more positive note, I thought maybe I really want to do something with quantum. Like, I really want to do an applying quantum chemistry project. Nothing too spicy or, you know, high energetic stuff like this. It's just something to actually demonstrate. Well, I guess just chemistry would be quantum chemistry demonstrated, I suppose. I know. Oh, there's one fun thing.
The quantum stuff like underpins all the theory we use
Hold
in
on, there's
chemistry.
one pretty fun thing. Hold on, give me a second. There's one thing which is pretty fun. Oh, I'm gonna send this image flame to you because you can appreciate it. I think it's not. Hold on, I don't have my headphones on by the way, so if you're saying something, I am so sorry for interrupting / not
Hello,
replying.
chat.
Has loaded. Buckle up.
Chat, he can't hear me.
But I'm gonna. Yeah. Okay. Listen, my teammates, my dearest teammates, I'll be right back. Just need to.
Normal visibility
I just need to share the pictures on the gram. Oh yeah, there we go. I'm back. So I'm going to send pictures to my patron only channel because they give me money and that helps me stay alive. There we go. And also I'm just gonna send it to you, Flame, because
And with that encounter,
I feel like it's not
I'm a
exactly.
patron with knowledge.
Yeah, there we go. It's not exactly in your area of expertise, but I feel like you could at least share my excitement.
Oh, is that? I
Yes.
think I know what this is.
Yeah. Wait.
Is that?
It is.
Wait,
It is the.
the one that.
Yes.
Yeah, that's sick.
Just trying to describe it without actually describing. Yes, it is.
Yeah.
I actually arrived early, so I'm glad. So that's what I'm
That's
gonna do
sick.
tonight.
I didn't know they'd look like that, but it makes sense because of the surface area.
Yeah. And so that's when I end this stream. That's the first thing I'm gonna do. I am terrified, absolutely terrified of breaking it, because it will be really easy to break, and I have to give you the actual reason for why it will be easy to break, but I can't say it. I'm gonna text it to you. So because of that, the thing you actually want is much easier to break. So you know,
Okay.
yeah. So the underlying, you get it.
Yeah.
Ali, do you want me to also message like what this is? Because I guess I should also that's a pretty cool thing. It was really expensive. Yes, please. All right, I'm gonna. There we go. I perfectly died just to explain it. It is a.
Do Domino's not do nachos anymore? What the hell?
Oh, you're British. You have. Wait, I think
They don't do nacho. Like what? Where are they? That's crazy. Damn. I don't even know what size to get.
Get the largest one. Always get the largest one. That's.
No, sides. Like
Oh,
side
sides.
dishes.
Oh, okay.
Yeah. I usually get the spicy chicken things. But I kind of want. Do I want garlic bread?
Yes.
I mean, it's a pizza.
Devil's advocate. Yes. Get the garlic bread.
Yeah, but like it's £7.
For you Brits, for a second I thought you were talking about like weight. And I was like, holy shit.
£7 to euros is like what, €7.50, €8 maybe.
I mean, yes, but like pound to euro, that's a pretty good conversion. Like pound to euro is like dollar to euro.
Yeah.
In Poland we don't have euros actually. We don't use them.
Well, pounds to dollars is quite big. I know it's like.
Wait, is pounds larger than euros? Are pounds? Is £1 more than €1 or?
Pound is worth more than a euro and worth more than a dollar.
Because euro is more than a dollar. I know that much. Wait, really? You Brits.
I think yeah, pound's worth more than both, unless it's like changed. Let me check.
You gosh dang the Brits. Make it just the ultimate edge.
Yeah, £1 is 1.17 euros.
Bommy, yes, I am gonna say it only to a couple of people because they pay me for it. Listen.
And £1 is $1.28.
Wait, how many pounds to euros? I was completely talking over you. I'm so sorry.
1.17 euros.
1.17. So it really is. You gosh dang
Yeah.
Brits, always hoarding of the wealth.
Well, it doesn't help us. Like, it's just more expensive.
I'm pretty sure we'll witness even more unforgettable moments.
The Jet Setters grab the cash box.
Do I get garlic bread or spicy chicken nuggets? Chicken
Why not
nuggets?
both?
Because the chicken is £8 and the garlic bread's £7.
That is a fair reason.
Oh man.
Have like a place.
I got
nearby?
paid £90
Me-
yesterday for Minecraft stuff.
Wait, what? Could you repeat that? What do you mean?
I've been like helping out a small Minecraft server as a staff member, and I just got £90 for like doing nothing.
90. I mean, if
But
they,
then- but
are they
then-
looking
then
for like
we
another?
agreed I should leave the team, like because they kind of realized that they didn't have a role for me, and so I was kind of doing nothing for a month, and then they just paid me.
Wait, do they?
But
Are they
I've
maybe
left now.
looking for? Oh, but is there anyone to fill your spot? Because I have like
No, the
available.
point was that like I didn't have a spot. They kind of brought me in, and they were hoping I would like find a spot, and I kind of didn't. And so I was there for a month, got paid, and now I'm not there.
I have just said, relax, you're paid, Ali. Not by make it. That is true. Ali is actually a D-paid intern. She pays me.
Oh, Ali, that's a good song. That's a banger.
Yeah, that is. Bob Benham just have bangers
Oh,
left
yeah.
and right.
I loved when he like made his whole thing and it like blew up
The
because I've
inside,
been
yeah.
following him for like years before.
Same here, actually. I mean, wasn't a huge fan. I just knew about him a fair bit.
Yeah, I
So-
mean, I'd watched like the shows, like the full these.
Yeah, I haven't-
done before.
I haven't done
The
that,
ones
but
he
I was just watching on YouTube.
apparently having panic attacks on.
Yeah.
Two consecutive cash outs.
But recently I switched
Yeah.
more to AJR. I don't know if you're familiar with them.
AJR.
AJR.
I
It's
mean, I know them. I think I listen to their songs when I'm in like a pop mood, but I'm a bit.
hell
nervous
yeah.
for Pop.
I just no, I go the other way. I actually listen to their songs when I want to be in a pop mood.
Oh, okay.
Yeah, I use them. I usually pop a caffeine pill and then listen to. Well, I have a playlist which is called "Fuck It, We Ball," which I use when I need to work on something but I don't have the energy. I pop a caffeine pill and listen to the playlist and just basically I have like a list of things I do in order to induce a manic high, which is really healthy. But you know, I'm productive then. It works. In case
For
anyone's
me,
curious.
I can just get in the zone, and then it doesn't matter what music I've got on. But it's like easier if I've got like electronic music in the background for me to like focus. But if I'm like fully in the zone, I can put any music on and it just doesn't matter. Like I'm locked in either way.
Outstanding. Cash
Like there were a few moments last week where I was like studying for hours and my brain was just there was nothing on my mind except the stuff I was studying.
That
That's
is
like,
actually-
that feels good. That's like locked in.
That's actually an impressive looking, especially for studying. Because I have it like a fair bit with 3D animating, for example. But that's easier because 3D animating doesn't require that much mental effort. It's actually not that difficult
Yeah.
to lock yourself in with 3D animating stuff, because then it's like an artistic thing. It's pretty easy. I myself absolutely love singing. I love it. I'm pretty awful at it.
Oh, you sing? Oh,
I mean, I'm not good.
I've done a lot of singing.
I'm not a good singer. I should make that clear. I'm really awful at singing, but I do sing a lot, and that's why. Actually, I love 3D animating too, because then you don't have to. When you read something, it's really difficult to sing. It's really difficult to sing when you read something, because then you focus on the thing you're reading, and then you can't really focus on 2 lyrics at the same time. The lyrics of the textbook and the song. That's it. And I'm thinking I'm the first person to ever refer to text in a book as lyrics.
Yeah, I mean, I've just been studying my textbook lyrics for my
Yeah, you know.
exams. So.
I mean, I'm just saying, it's similar.
I used to do a lot of singing from like a young age. I was singing and I was in like some school choir stuff.
Have you noticed how
And-
people who like don't like singing usually are just sadder in life? I'm just saying, correlation or causation. Like, it's
I
usually.
used to do these performances though. It was like I would do. So I played piano as well, and so I would learn these songs on the piano and sing at the same time, so you can like self-accompany with no
That's-
backing music. And I would like I did some big solo. I think my biggest one was in front of like a few hundred people.
I only did 2 songs like that on the piano and singing at the same time, and those were from Alexander Hamilton, King's George song. I don't remember which one exactly, and City of Stars from La La Land.
Oh, that's a good one.
City of
That's so good. Yeah,
That's a really good one. It's actually very
that's one of my
pleasant.
favorite movies. I really like that movie.
La La Land?
Yeah.
No way! Oh, that's my favorite. I was like last stream. I was talking about La La Land.
Oh, were you?
Yeah, it's my favorite.
It's a really good movie.
It's my favorite movie without an ending. It doesn't have
Yeah.
an ending.
What do you mean without an end? Like,
It
because it
doesn't-
doesn't resolve.
No. It doesn't have an ending, and that's just propaganda. It doesn't have an ending, and it ends like 20 minutes before its runtime is over, and then it's just a black screen, and then they just live on the happily ever after.
Oh, you're saying it doesn't end sad.
Yeah,
That's,
precisely.
that's what you're saying.
Yeah.
Okay.
Yeah. There's no ending. There's no ending. They just, you know. I mean, pardon everyone. I'm sorry for spoilers, but like, she stays with Sebastian, and they just live on happily ever after. You know.
I mean, I
with
feel
a-
like sad endings have a meaning to them.
Yeah, but you know, there's no sad
wouldn't
ending in that
be-
movie.
It
Actually.
wouldn't be the movie it is if it wasn't a sad ending.
But yeah, it wouldn't if there was a sad ending, which there isn't. So you know, that's an important thing to mention. Also, recently I've been watching a lot of Disney animations. Like, holy, Disney is getting a lot of crap for just being about profit. So, for example,
Well,
the
I mean,
Marvel
that's
movies.
all companies. That's like,
Yeah,
that's
I
the
mean,
point
that
of
is the end goal of all
companies, isn't it?
companies, right? But they don't get nearly enough credit for their animations. They could.
Disney's really hit or miss, I think.
I don't know.
Because
for
you know
me-
Wish, like you know that one that came out.
Yeah, okay, the
recently?
wish
It's
isn't.
my mum was like doing work and she was like,
"Oh, can you just put a random thing on?" Because we'd finished watching Netflix. She's like, "Oh, just pick something and put it on." And I was like, "Oh, Wish is here. I've heard it's really bad." And she's like, "I just put it on." I came downstairs like an hour later, and I'm like, "Oh, did the film end already?" And she's like, "No, I just hated it so much,
Okay.
so much. I had to stop working and turn it off."
It's not
Which was crazy.
that bad. Okay, hear me out now.
She said she just disliked, like she wasn't even watching it, and she had to stop.
I mean, okay, it certainly was. For Disney, like, movie standards, it is bad. But that's for the Disney standard. I would say it's not too bad. Like, okay, first of all, it has a lot of singing in it, so I'm biased already. Like, This Is the Things I Get is probably one of my favorite villain songs out there. I mean, I feel like it's really close to being perfect. I can't quite put my finger on what. It's like a weird ick. Like you won't relate to this as much, but when you do something artistic and you rush it, there is a certain point where like something is wrong, but you don't have the time to actually figure out what that is. Just
I get that, yeah.
yeah, there's something just off. I get that a lot of videos, like electric versus electronic is over an hour-long video, which I hate, precisely because I rushed it and now it's bad. And there isn't like a single reason for it. It's just bad because I rushed it. And so for Wish, it's a very similar thing. And This Is the Things I Get is a phenomenal song. If only they like tried a bit harder. Damn it. Encanto though, I love Encanto.
Oh, Encanto
Surface-
was great. Oh, I love
Surface
that.
Pressure is the best song in Disney, and that's a hill I'm willing to die on.
Nighttime here.
I was kind of just a we don't talk about Bruno fan.
Yeah, we don't talk about Bruno as a
Bit
classic,
basic,
but
but-
Surface Pressure, I really love
Yeah.
it.
Enemy spotted up there. The socialites are in the limelight.
Also, the big reveal when it actually turns out that, like, you know, they were on Earth the entire time.
Scotty, this could get really
I know how many
chaotic
people
really
get that
fast.
reference.
You mean the really old movie?
Planet of the Apes, I think it was.
Yeah, yeah.
Why is always that used as like a prime spoiler thing? Whenever anyone wants to, whenever anyone needs an example of spoiling a movie, it's always Planet of the Apes. Such a bizarre movie to reference. Have you seen
Really, I haven't
Saw?
heard anyone spoil it like that.
Have you seen Saw?
I haven't. I've seen like clips of it, but I haven't seen it.
I mean, I thought I knew what this movie was about just based on the things I seen about it, but that's not it. It's just, I think it's the best switcheroo plot twist I've ever seen. Like, that's, you know, people think that in Saw is about the torture, and yeah, that a fair bit. That is a big part of it, but like the main thing that Saw movies do is the plot twists. And I think at this point there are like 9 Saw movies, which that's called the series, not movies. But there's around 9 of them. I think I've watched them up to the 5th one. And even though I was full on expecting plot twist each time, I knew that plot twist was coming because it Saw. There will be a plot twist at some point. I was full on expecting it. I still didn't get them in any movies. I think I got in one movie. The first one, if you can guess what the plot twist is in the first one, you're a prophet. Like omniscient kind. This, yeah. I'm the strong one. This is the things I get. This is the things I. Also, the villain in Wish was very weird.
I just heard that like it just didn't have any like substance to it. It
Yeah.
was just very one-dimensional.
There was, yeah, because usually you have like a deeper thing going, but no. Oh, Strange World, I think that's what it's called. Also very recent. I feel like that's the last Disney movie before Wish. Strange World. And
Yeah,
that's what
I remember seeing a trailer for that, and it was like it looked like a nothing movie. Like there was just nothing going on.
Surprisingly, it is really good actually. I really liked it. And it had a good plot. It had a plot twist, It had a deeper meaning, very important in my opinion. It was really good. I think at one point they tried to like foreshadow the ending, as in foreshadow the point of the movie, and they did it in a bit of a too obvious way, but it didn't ruin it for me. It was still really good. It wasn't a musical, so I'm biased against it, but still it was pretty decent. Make it in his denial arc. I'm always in my denial arc. Have you heard about this constant called mole?
I'm about to order, and it says marketing preferences, and it says when you place an order, Domino's will send you occasional marketing offers and promotion. Please select below if you do not want to receive this marketing. And they've got these 2 checkboxes, and so it's like you look at the checkboxes and you're like, okay, I'm not checking these, but you have to check them to not get marketing, which I hate that. I hate that so much. You have to opt out of it as you're placing your order, because placing your order just opts you in automatically. It's, oh my god.
Loves in European Union. I wonder what that's like. I'm a huge Euro fanboy. Because like Europe is
I'm
willing
so sad
to
we
go.
left the EU.
Yeah, Europe is willing to go to war just so that I wouldn't have to check a checkbox. Europe is willing to go to war just so that like a random company would have to tell me when they, I don't know, save my hair color or something. And I love it. What's really funny is that for most British people I've talked with, they also didn't like the fact they left the EU.
Well, you got to remember that most of the British people you talk with are like people who know what the universe is outside of the UK. There's a whole demographic of UK people that are just like,
I guess
don't know the outside world.
people who want to leave the EU probably on average aren't interested in science.
Well, it's not just that. It's also like if you're speaking to people online, they're gonna know more about the world around them. And
Well, not always.
but yeah,
there
it
is echo
depends.
chambers.
But on average, and also like
Well, I really hope there isn't
yeah.
like an incentive for big companies that manage social media to like alienate people and put them into echo chambers where they will just grow more hateful towards different
surely
groups.
not.
That would be awful.
surely not.
That would just
No,
suck.
the UK is like South UK is extremely diverse, and especially like I'm from London, and it's like half my classmates were like Asian or whatever, and so it's just there's so much diversity in the South. But then up north, it's just there's no diversity, and everyone's very like nationalist on average.
Opposite of America. No,
Yeah, America's a whole.
also Ali said, I think choosing Domino's is the issue, Flame.
Yeah, that's a good point, Ali. We don't have much pizza choice here. I always get sad when I come back from Italy because the pizza in Italy is so good that when I come back to the UK, I have to like not eat pizza for like
Don't take this
2 or
wrong,
3 months.
but you sound really posh.
Well, yeah, I know I do. The thing is, I'm not actually like posh.
That's precisely something a posh person would say.
Well, no, I'm not. Like, my mum has like high income from.
I
She's a
wondered,
software
I
engineer,
wondered how
but yeah.
how like common of a word posh is. Like how many people in chat watching right now know what posh means? Because I feel like it's well, in UK it will be relatively common. I hope at least, because y'all made up the word, y'all better use it. How
To be
many?
fair, the only times I've heard people say posh have been when like telling me my voice sounds posh.
I mean, I really like the word posh. It's very nice. Posh isn't an obscure word. Wait, is posh an obscure word? I have no idea. That's what I'm asking. I
Yeah, I
can't
think it
tell.
just depends. Yeah, that's what you're asking.
I feel like you have to be posh to know what posh means. Posh sounds like a very posh word. It sounds very Royal Englishy. No, I don't think it is. Neither do I. But you know, we are biased here. We do be insulting Brits left and right. So, considering how often I make fun of British people, you know, like, no offense, Flame. It's just that British people aren't people.
Well, I'm only half British, so it's alright.
Yeah, so
I'm only half offended.
the only thing I like more than making fun of French and British is making fun of both of them together. I really like though the fight against the I don't know what to call it. No, it's not quite the racism against the British and French.
Xenophobia.
Kind of, yeah.
When you say xenophobia, it sounds really serious.
Yeah.
Like it's just banter.
The reason why I like it is because it's not really that harmful.
I don't get the teeth thing. People say like British teeth, but it's like I
Yeah.
don't see any difference outside of the
Also, what's
UK.
really funny is that if I do remember correctly, like in Britain you have better dental health hygiene on average than
Yeah, our dental
America,
care is
yeah.
great. Like you just, yeah.
there's a statistic.
Someone once told me that he thought I must have had braces because my teeth were so perfect. And I was like, what are you talking about?
One thing which I find really funny
With only 30 seconds to go,
is how
our
every single
contestants are
country
still bringing the action.
thinks it's more famous than it actually is. Okay, maybe for America and Britain that's not the case.
Setting a zip line.
Two big boy English speaking countries, but like for most countries they all think they're more famous than they actually are, especially when it comes to Slavic ones. Like Polish people think.
No one knows Slavic countries, honestly.
Yeah, yeah, that's fair. They're all
Like
the
I
same
only really
anyway.
learned properly about like Balkan countries when I was dating a Croatian girl, and that was it. I just didn't really know much about that area.
Crash their party in the next
I am
It's
jealous.
like, oh yeah, Eastern Europe, just whatever.
Yeah, there isn't much here. It's mostly like, you know, you mostly just get drunk and then black out and then be like, oh yeah, I must have forgot what I saw, and that's how we hide the fact that we have nothing here. I am jealous dental care that is free there. Is dental care free in Britain?
I think it's free until you're 18. I remember I used to always, well, was it even free? Maybe my mum was paying for it or something, but it was like, I think it was free until I was 18. And so I'd always go and I would show up, do the thing and just walk out. And then I turned 18 and I went there for the first time after I turned 18 and my mum like booked it for me and I went there. And I turned up, did the thing and walked out. And they phoned my mum. They're like, "Oh, you have to pay." And so she had to come back. Oh my god.
Walked out of paying. And what are they gonna do? Break them teeth? Like, I'll buy a hide fish, by the way. Hi. I don't think. Well, free healthcare isn't as free as you Americans would think it is. I still think it's better. I like free healthcare because, like, I can just.
I know American healthcare is just broken.
It's awful. It's really awful. My stream says hi, lol. Well, hi, the Fisher's stream. Welcome, make it.
Hello.
And this is Flame.
I'm Flame.
A clear evening sky in
Random
the arena.
chemistry.
I'm glad how, like, I talked over you to introduce you when you were introducing yourself.
Of their opponents.
Sharp Flame. Yeah, this is Flame, everyone.
Vault 2 is being unlocked by the socialites.
Welcome to the #1 final streamer who's cosplaying as a scientist.
I think I am gonna go now because my pizza's gonna be here soon.
That is fair. Oh, you're not gonna share? That's mean.
We've got our first
Well,
elimination
I've
for
ordered a
the
whole
match.
pizza and I'm only gonna have like
Getting
half of it.
acquainted.
Well,
you
you
can
could
get
share the second half.
Yeah.
I'm also gonna end soon because it's been 3 hours,
long one.
over 3
Yeah.
hours. Yeah, so that's especially since this spin research messed me up.
The spin. Oh god. Okay. I'm gonna dip.
All right,
Fun.
looks like pizza. They were funny.
Yeah. Pizza dip.
All right, bye then.
See ya. Bye bye.
So everyone else still remaining here. Question for you: what conversation topic? Free healthcare isn't a good thing. I would say it's still pretty good on average. It's just not as free. That's the problem.
The mighty grabbed a cash box.
I'm gonna call something free. Mine's insurance thing, am I right? Oh, they're stealing it.
Reflexes after that attempted cash out heist. Nice interception.
Oh, we still have it.
The socialites are back. Team respawn.
When are we playing Don't Stop Together Make It? Well, are you free right now? I have to work tomorrow though. Precisely! You always like, when we're gonna play, but never actually... Always the bridesmaid, never the groom. Playing game today, make it? Yeah, it's crazy. That's very, how not in character of me. Oh, you want to watch me and Ali not starving together?
Contested. Very impressive teamwork there.
Wednesday, but I thought you were ending soon. Well, if you're gonna play, we're gonna play, then I suppose I'm not ending. I do have low walk, but it's fine. I'll play Don't Starve with you. Oh, you can fire through this. That's bad. I have no idea what Don't Starve even looks. I have no idea what Don't Starve is.
Scotty, someone meddled
I
with
have
their
walk.
money.
I always have walk.
Great move there by the socialites, stealing that cash out.
Aggressive and impressive.
There's the entrance. That's where the entrance is. Okay. Got him.
Smokes out. Preparing explosives. The mighty are back in the arena, folks. Vanish bomb out.
Technically, actually, we could just wait like 1 hour and we could just do another stream. Because technically then that would be the next day.
Enemy spotted. In there. It's in. The tough shells make a bold statement with the first cash out of the match. Time to disappear.
Yeah, so I'm just gonna go set up like an animation. Ah, almost. So close. Get some food new though in the meantime. I've been nibbling this entire stream.
Thanks. Much obliged. Big thanks.
Oh, we're winning by the way. We're winning in the background. I wasn't even paying attention to the game. Just playing on hunch. Ali, better question. When are we gonna play the finals?
In the arena. The ultimate omen of mayhem here at the finals.
You don't want to stop. I wonder how can I do it efficiently? Because on one hand, I have like a practical thing I should do today,
Siphoned by the tough shells.
and that's gonna take a lot of time, no matter how I slice it. And I can't really stream in the meantime. And on the other hand, I do want to play Don't Starve. Choices, choices, choices. Ah, ow. No good at FPS. Neither am I. Just pretend.
We're
Like me.
halfway through the round, and there's been plenty of action. Let's see how.
I'm actually missing every shot if you pay attention. This is not even me joking. I really am missing almost every shot. Content warning would be great game to play. Content warning, you say? Wow, we should really Ali, you have content warning maybe. We should really play that. That's like a swell idea. We've done the yeah, we did. Me, Ali, and Tefta. We did as a group of 3. Did our teammate? No, Lord McNuggets! Damn it! My lord, no. We could do that again.
Cash out in progress thanks to the Vogues.
We haven't gotten far in the game though. Alright, give me this. Just one. There we go. Oh, this is gonna work. Oh, I have such a swell idea. Oh, I have such a swell idea.
More plight than
Welcome to 5D chess with Make It. There wasn't a plan behind me, was there? Make it for the next time. Oh, yeah, make it. Yeah, that's
The
funny.
socialites are dazzling the crowd. They're opening Vault 3.
Can you block me for 5 minutes and then unblock me?
The mighty just made their return to the arena. Placing a gateway.
Oh yeah, we should have played it way more carefully because like we're only playing as a team of 2. Whoops, sorry about that.
They got me. The socialites swooped up a cash
Oh, that was also smart then.
Time to disappear. Great crowd out. would be a mighty big shame, but the mighty are in danger of being eliminated from the tournament. I'm going to revive. Hold on.
Is that an enemy out here, or I'm just excited to see me? Oh, okay.
By the tough shells. Good steal.
Now that's how you play to win this game show.
I was really hoping to steal it and then escape. It didn't work.
Fantastic steal by the mighty.
You've done nothing. Just don't tempt him. Lampos are still here, by the way. Lampos.
The socialites took another team's funds. Move up on cash out D.
Ah, yes.
The spotlight is now on the socialites just like they like it. They've cashed out.
Make will just have memory problems, so if he does that for 5 minutes, she will forget about you. That.
This is gonna get
No,
very interesting
Ali wouldn't.
very fast.
There's like a stereotype of med student of how they memorize stuff all the time.
Feel a little sting from our laser. Okay. Little.
The Vogues have been rattled. Team wiped.
I hope they aren't planning on making this a trend.
Just go all wrong now.
Whoa, rapid fire
True
takedowns.
but rude. Listen, that's how it goes with Happy, okay?
Opponents in one go.
That's just what Happy be like. Listen, Ali, it stings because it's real. Don't blame the man. No, Happy, don't apologize. You're spitting facts.
The mighty denied a cash out. Great steal.
But HD does sound this dolphish. Okay, yeah, that's what I'm gonna do. I'm gonna end the stream, go eat something, do the 2 practical things I was supposed to, make like 2 or 3 3D animations, and then we'll have them render on stream.
The Vogues denied a cash out. Great steal.
Oh damn, we were actually so close to...
Cash out complete, and the Vogues
Oh, this is not gonna give us nothing. If we get wiped, it's actually pretty bad for us. No wait, if they get wiped, that's good for us. Nah, wipe them. Yes,
10 seconds.
1 heavy remaining. Where's the heavy? Gotta kill the heavy. I think I found the heavy. Damn it.
The Vogues are the team to beat in what promises to be a sensational final
Message me when
round.
you will play. Alright, alright.
Winning are the socialites.
I'll take my focus meds so I'll be awake on stream. You don't have to. Don't do amphetamines. Alright, I'm gonna go now. Eat something. Do the practical thing for a YouTube video which patrons know about. And then I'm gonna do something for another practical YouTube video, which I will message patrons about the second I'm done. And then I'll do 3 animations for another video with yeah, and then we're gonna make another stream. So for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.